All right, there we go. That in theory should have done it. Does it work now? Oh, man. Sweet. It seems like there is a decent amount of lag between comments and audio. So this is like the first time I'm doing YouTube streaming for real. I sort of did this a little while ago, but I like all set this up fresh this morning. So, hey, what's up, Adam? So I'm kind of like working the kinks out of all this. Trying out YouTube this time instead of Twitch, mostly because I think if I'm going to stream more in the future, I'm probably going to stream my video game stuff, which I've been working on my YouTube channel. And I think I'm going to stream on YouTube instead of Twitch. I don't know. I haven't decided for sure yet. It's interesting and complicated, those decisions. So I figured I've been streamed on Twitch a bunch before with my programming stuff. Might as well give the YouTube a try this time. So we're going to give that a shot today and see how it goes. So the general situation. Awesome. Thanks, Mike. Basically, we did not yet get the theme for this language. So I have an idea of what I want to do, and it's pretty cursed and pretty silly. So we're going to see if it fits the theme. I hope that it does. And if it doesn't, then we'll come up with something else. But basically, it's kind of the way I always have to do it with these sort of jams is like think about vaguely what you want to do and then actually end up doing a thing that fits with the theme. Yeah, we don't totally know yet. It's going to be announced in 10 minutes. Also, if you see me looking down, let's see how this works. Let me just mess up my camera real quick. Oh no, I don't have enough pull on the. Oh, there sort of we go. Oh no, can't quite see him. There he is. Mateo's down there. He's got this nice bed to sleep on, but sometimes he doesn't like to sleep on the bed. He likes to sleep on the floor up against my chair. Lightning, I'm going to be using Rust. So that's the thing. Part of that is just because like it is the programming language I enjoy using the most. Part of it is because the idea that I have for the language I'm using, Rust has some really good libraries. It has good libraries for building pretty much any programming language, honestly, but specifically my really cursed idea for this language, Rust has a library that I want to use. So I'm going to be doing that. And then as you can see, I got VS Code here. I also happen to have new shell, terminal window. I can pop that up. It's going to be a little awkward because I don't have like fancy a stream deck or like fancy key binding settings. So I have to like manually go into OBS and click show this window and show not. I decided that was a little easier than setting up a whole ton of like random transitions and stuff. Maybe, Lucas. All right. Yeah, YouTube yelled at me for the settings, but I guess it seems reasonably decent to you all, so I'm just going to leave it. It's complaining about bit rates and stuff. I might mess with it. I'm not going to be streaming for 48 hours straight, obviously. I plan on being relatively chill about this, so I'll probably mess with it a little bit in between whenever I take breaks. I think I'm like shooting to roughly stream until 7. Hey, bud. Now he's mad. You can see there's a dog outside somewhere. He's really upset. Mike, I am in Central Standard Time. I am planning to start and go at least Glad to hear it. I'm planning to go until basically about 6:30, so another like 5-ish hours for this first one, because this little guy right here, he's gonna need to have, buddy, he's gonna need to be fed dinner and be taken on a walk. So like, I at least will be taking reasonable pauses in order to take care of the dog. So usually, like, he gets fed. So it's almost 1 o'clock here. He usually gets fed at 7 and taken on a walk, and then goes out to go to the bathroom one last time before bed at 9, and then stay up. So I'm guessing this day is probably going to be basically like me doing everything until probably about like midnight ish. We'll see how it goes. I'm pretty much gonna play it by ear. This is like a fun thing for me. So if it starts not being fun, then I will stop doing it. But I think I'm pretty excited and interested to see how it goes. It shouldn't be super hard. I'm also not 100% sure where exactly I want to like stop, because there's always more things you can do, right? So, oh, there we go. Let's move this camera just a little bit. There we go. Get that guy in there. Yeah. Good boy. He's chilling out. Yeah. So my plan is kind of basically like go until either I feel like it's done, thanks, or I want to stop, or all those kind of things. We'll sort of see how it happens. Yeah. Hey, super narwhals. Yeah, I this language is going to be dynamically typed because I don't feel like implementing a static type system. And I don't know. I feel like for these kind of 48-hour things, doing something that's a little simpler overall is good. Since I'm working on myself and not a team, that also kind of restricts. Buddy, calm down. See? If the dog barks a bunch, I will mute my mic so you all don't have to listen to barking, because honestly, I get upset when he starts barking. So I don't plan on having a forever problem, but just like sometimes there's other dogs in the building or outside and he hears them and he gets upset. So hopefully he'll just be chill and sleep. Usually he just sleeps all day right there. And so it's wonderful. But I guess he knows I'm streaming, so he wants to act up. It's true. Mateo is a good idea for the name of the language, except for the fact that I think the language is bad and I think that he is good, and so that's the only problem. The problem with that, I don't want to taint his name with this ridiculous language I'm gonna make. All right, let's check in on the Discord and see if JT has said anything. Yeah, lambda calculus, but where lambda is bark instead. All right, 4 minutes in theory till the theme happens. Yeah, so it does have an idea. I don't know if I would call it, it's, given that you put big idea in quotes, I'm assuming that you're referring to something sort of like what John Blow is like talking about, basically. And in that sense, it is a big idea language. However, I don't think that it's a actual big idea. It's a pretty small one, and so it's more like something interesting and silly, basically. So we'll see. I think it's more like a troll idea than it is a like legitimate breakthrough language kind of thing. I just wanted to do something very silly, and so that's what I'm going to do. Yeah, we'll see. I wanted to give it a name, but then I was like, oh, if the theme demolishes this, that's gonna mess stuff up. So I pretty much I'm just gonna wait and see what happens. Lulz would be a pretty good name. I have a small idea, but we'll see. We'll see what goes on. The problem is you gotta. Yeah. So that's a good question, Lightning. I have played around with all of them. In fact, like I've known the guy who makes Nom, Joffrey, for a really long time. He's been around Rust for an extremely long period of time. And I even went to a conference in Nantes and hung out with him for a while, and that was pretty cool. Serde is great, Pest is great, but I don't want to talk about what I'm using because that's going to spoil my idea. So we'll talk about it more when the theme happens in just a second. JT says it's about to get posted. Mike, I've done a little bit of compiler and language work before. I'm on the core team of the Rust programming language, although the implementation and the language itself is not my job. However, I've been like around language design like for the past, I joined the core team in 2014 and I've been working on Rust since 2012. So like I've been interested in languages and doing stuff for a minute. The last silly little language I made was an interpreter for brainfuck that used emoji only. So that was a fun thing. And yeah, Lucas, like sort of the same thing for me. So I used to maintain the Semver implementation for Rust. And basically, like recursive descent is the way to go. I sort of think in general, unless for programming languages, handwritten recursive descent parsers are the right answer. I think that if you're doing something like a file format, then using libraries makes sense. But if languages have additional like HCI requirements, basically. Oh, ooh. The theme has been announced. It is first class comments. Interesting. Okay. Let's see here. Okay. So that is amazing and ridiculous. And I don't know if it is, all right. So let me take a step back here. Yeah. So I'm going to bring up my terminal because let's just write down stuff in here, in VS Code. It's a little scratch pad. All right. So first class comments. So that is amazing, and ridiculous and hilarious. Wow. All right. That's interesting. I got to think about this now. So the language that I wanted to make, my idea is, I described it originally as homoiconic Tamil. So that was kind of like what I wanted to do. Now, if these words don't mean anything to you, you may not be around programming languages a whole ton or be like a Lisp person. Basically, homoiconicity is this property where, oh, hey, what's up, Gad? So homoiconicity is this property where the programming language's syntax is also its data structure. And so it lets you manipulate programs as data really effectively. So Lisp is kind of the most famous language variant that made this happen. And so what I kind of wanted to do was make a programming language where TOML is the syntax. And this is what I mean by being trolly, and also like it is a big idea in the Jonathan Turner sense of like, or Jonathan Blow sense of things. And so like I kind of wanted to be like TOML is the syntax. So I hadn't really completely thought what hello world would look like yet, but I kind of felt like basically I should do something where it would be like this. So this was kind of the like, this is where I was sort of going with it. I forget if these can be bare words or not. I think they can be bare words. This one probably should be a string, but I think because these are named, this would work okay. I actually don't remember. I specifically, in the spirit of a jam, I didn't want to like look up too much. So I don't 100% remember all of the details of TOML's exact syntax because I don't use all the details. But I thought this would be like an appropriate, hilarious kind of like way to do this. So I think that like from here, this is kind of where I got a little like less sure about it because I'm not 100% sure how the separators work. So I think I was going to start off with just like strings for lines basically. So like, but then this gets really weird because of the quotes. So I wasn't 100% sure about that, but I think something like this is totally fine. The real question though is with first class comments. So let's see. Let's go to TOML's actual. All right, I'm gonna do this. I'll actually bring up a. One second. Here we go. All right, so here is the TOML specs details. So this is all fine with strings and stuff. Let's go into the full spec to actually see what's going on. This is also why I said I got a little bit about the parser thing. So part of the reason why I wanted to use TOML as the language for the syntax is because one, I think it's really, really funny. Two is because I don't like parsing. Like it's the easiest part of making a language in some ways. Like it's kind of the one that's like solved basically. I don't think that's actually completely true, but like a lot more research goes into optimizations and code gen these days than does parsing techniques because parsing is not usually the bottleneck anymore. Anyway, so like I personally don't like it. So I was trying to think about like what could I do in a way that would make me not have to worry about parsing. And then I was like, oh, if I use a well-known format for the syntax, I could just completely ignore parsing by, using a library for it. And given that we only have 2 days, like anything you can do to save time is worthwhile. So I can just completely ignore all the parsing by using TOML as my syntax. That's kind of how I came up with this idea. So I know, yeah, you're totally right, Cad. It's not actually solved, but like, and I do, let me put it this way. I guess like all the academic stuff is not as relevant to the things that people are actually doing for production languages. It's definitely closer to solved is the more accurate thing, but it's good to have, it's good to be trolly sometime. Okay, so comments. A hash symbol marks the rest of the line as a comment, except for when inside a string. That is the only thing that TOML says about comments. So in terms of making comments first class, this is a more interesting kind of thing to do. So it turns out, also to answer my question about the bare words arrays. So arrays basically need to have strings or other like types in there. So yeah, so this actually would need to have strings for the body. And so that kind of is like not super ideal. So that's going to be kind of gross. I wonder, so it's kind of funny. I'm trying to think about like what I could do with comments to be interesting in this, because like this is kind of one of those things where, yeah, it's like Like I could make comments the actual like statements, because like one thing that would solve this is like bad, so it's not necessarily what I'm saying I want to do, but like I could in theory do something like this. Now I also was thinking like I'm not 100% sure too, because this is like regular. Yeah, exactly. Hey Ozio. I totally agree with you, Cad. Like it's interesting. It's like almost like, I mean, you could argue Rustdoc has first class comments, right? But I think also, okay, so like let's see here. So like one thing I could do is turn it's like I'm thinking about something like this. This would be an interesting way to kind of do. Oh, sorry. Nice. Good call. Thank you. Turning off the browser window. All right. So appreciate that, Joe. This would be one way to do the syntax. Like, so you could do it so that it's like the body is an array of tables, and the tables have the function name as the key, and then the like arguments as the body. So like, like we could do something where, well, the problem is then there's not a good way to declare variable names is kind of the like the thing. Yeah. The theme is first class comments, Lightning. I have it right up here at the top. So interesting. See, because like the problem here is like, say we wanted to do this might actually not 100% be, maybe my idea for TOML is not actually quite good enough, or I should have thought it about a little before. Oh yeah, treating braces as invocation. That's true. Yeah, so like I was kind of thinking about that for multi things, because you can do it like, since TOML's so dynamic, you can do kind of both. So this like would make total sense. I think the problem is not knowing what's a variable and what is a bare word, because like if the sorry, sometimes I pause and it's not clear if it's like the stream is frozen or something. I guess, yeah, I guess the major issue I'm running into with this idea for syntax is that it's unclear to me. Yeah, this is what I'm trying to go for, Alex. Is some sort of square Lisp. Dotted keys help. Yeah, they might. Bare key. I wonder if like I could. Oh, I moved the. There we go. I wonder if like you could. So I could require you to do something where it's like. This is so gross. Let's see, like. So like you could do something like this, and then that would mean you have these variables pre-assigned. It's like nothing says this has to be a good language, right? Like I'm interested in making this language terrible specifically because I'm not interested in a good thing. A sigil could work, Mike. Yeah, you're totally right. Like if we interpreted the start of a thing as uh, a variable, that would totally make sense. Yeah. Yeah, that might be true about fourth. I don't 100% know. Yeah, this would kind of like. So what's kind of funny is like the history of. Yeah, that's good, Cad. Are you actually going to build that? Are you going to go off and make that happen, or you save that for a future one? Yeah, like what's interesting about this is actually, let's see here. I'm gonna. So hilariously, really old. All right, have fun. Good luck. I'm interested to try your language whenever you do it. So really old C actually had a different way of defining functions. So you would actually say the name of the function and then the argument list, and then you would define like a variable declaration before the opening curly brace. And that's how you would actually define functions. And so this was actually like extremely early C. And so ironically, I think this syntax kind of like mirrors it in some way where, but instead of it, it's also sort of like really old C, not really old. I think it's pre C89. I'm not 100% sure exactly. I kind of forget, but older C requires you to declare all of your variables at the start of the function. And the reason that that happened was basically like you wanted the compiler to be able to work in one pass, and so you wanted to be able to know before you started doing code gen for the actual like programs like body how big the stack would need to be. So like there is some precedent for something kind of like this as a thing, but it is definitely gross. Um, Yeah, what if comments are statements or commands? That's definitely an interesting idea. I guess these args need to be in quotes. I wonder if, just like thinking about it really quick. So thinking about doing like, what does first class even mean, right? Because there's sort of the intuitive understanding of first class, but what does first class actually mean? Wikipedia basically says in programming language design, a first class citizen of a programming language is an entity which supports all the operations generally available to other entities. These include being passed as an argument, returned from a function, modified, assigned to a variable, stuff like that. So that is kind of interesting. I wonder if, all right, let's look briefly at the TOML library that I want to use. Let me turn back on the browser here. So, okay. Where is this window? There we go. All right. So there is the TOML crate, and that's sort of the default one that exists. However, I know also like this isn't the only crate. There's also TOML edit, which is format preserving. And part of the reason why I kind of wanted to do this whole thing as well is because TOML edit is used for cargo edit. And there is a Rust bug to like put cargo edits functionality into cargo itself. So we can do like cargo add foo. I really want to see that happen. And so this, like the TOML crate is used by cargo, but TOML edit is used by cargo edit. There's this whole big thing about merging the two and upstreaming them and all that stuff. But I think one of the things I'm interested in is how this is actually like represented as a thing. And so this like lets you modify TOML documents while preserving comments, spaces, and relative order. And so this like should actually kind of like give us the ability to like actually like parse out something. So I think what I'm going to do here is I'm going to, let's hide this and bring back up the terminal. All right, so the first thing I need to do is actually create the project itself. And so this means we need a name of some kind. And so I think what I'm going to go with for now, let's make cargo init in the current directory. So that way we have that going. And I'm gonna hide my terminal again. Now we have our source in cargo.toml. This is just called Steam Clavnik, which is hilarious. I'm gonna call this temporarily for now tins. Toml is not syntax, because I think that's hilarious. Oh, nice. Yeah. Okay. Yeah. Right. You're just defining your language as strings. Let's grab toml edit and put it into here. And then what I'm going to do is I'm going to grab main.rs and I'm going to grab the example from this. I'm going to put it here. And we're going to take the toml that I made in the README, and we're going to paste it over in here. That is not the right thing at all, really. There we go. All right, and so we're going to then all right, so for now, what we're going to do is we're going to grab this. We shouldn't need external create toml edit. So we're going to take this. We're going to, oh, that's the emoji. We're going to parse this. Thanks, Narwhales. Yeah, it's definitely, this is a hard theme. Like this is like a good theme. It's actually difficult, I think. So let's just see what the data structure is that gets parsed when I do this kind of thing. Because I think that'll be kind of interesting, especially since I would sort of like to have a language that can like mess with itself in some sort of like ways. I want to see how this parses and like what this prints out and such. So let's go back to, I guess I can bring up a terminal inside of VS Code. That way I don't need to keep switching back to showing you guys the terminal versus not. Yeah, TrollML is that's actually a really good name too, because it sounds like the toml and then ML for meta language. All right, so we got a document and it's got a table at the root and it's got an items of the table, functions, key value, blah, blah, blah. Array of tables, which makes sense. And then the values, we got a table with table, and name is main, and args is totally a thing. And it's going to get argc is the string, and argv is the string. And that's all good and fine. Then we have the variables table, which makes sense. Got int and string. Then we have our actual body. And so this now does actually values, inline table items, key, decor. Oh, right. Wait, print. Interesting. So it looks like, oh, right. This is so big. I can't actually see it. So it looks like what it ends up actually having this as being a value with an inline table print hello world. Really? Oh, it's a prefix. Interesting. Okay. So it looks like the way that this library represents comments is by using this thing called a decor. That's the prefix and the suffix. This kind of makes sense, right? If you're thinking about a library that wants to parse the actual syntax of the thing, it would, and it's preserving the formatting, it needs to keep the stuff that's before and the stuff that's after in the thing. And this does have implications. Like, since we're kind of like developing the language around a library, this means, for example, I couldn't make the language do this. Like, let's say that I wanted to do it so that each line was something like this. This would now be an empty table, and it would just have this as like a block of text, basically. So that has implications on language design, which is kind of interesting. So yeah, so I guess it's gonna keep track of comments as being attached to a particular node of something. So interesting. So yeah, that helps in terms of like constraining the design space a little bit, but I'm still not 100% sure what to like actually use first class comments for. Yeah, I mean, this definitely does like have some amount of inline comment ability. Yeah, new line, according to the TOML spec, starts with a hash, goes to the end of the line, and hits a new line, and that's it. So that's the valid comment syntax according to TOML. And I believe that's like, if we would change, let's go here. If we change this to say like, we change this to do this, then when we rerun this, it's going to say, oh, interesting. Preamble's print hello world, but suffix is nothing. Where did that go? Oh yeah, here. And then, interesting. I wonder what counts as a suffix then, because it's put the prefix onto, it put the prefix of it onto this. It's considered a prefix of this, not a suffix of that, which is pretty interesting. Yeah, that is a good point. Expressions are going to have to be on multiple lines in some fashion. Huh. I guess, all right, so I'm trying to think about what first class actually means here, because the biggest thing is not actually how to move forward with the language in general. I think that this is solvable and these are all totally fine. I think that the real interesting question is what a first class comment means. So like being able to assign comments to variables, being able to modify comments and print them out, doing stuff like that. that all is like a thing, but really, like, I don't know what that would mean in this syntax. And I'm like a little worried that this theme ends up killing my idea because of the restrictions between comment syntax and TOML, and the fact that it already, to be the syntax of a programming language, it's like pretty restrictive to have TOML as a syntax. Like we're already having some small problems with like figuring out how to fit it in. And so I don't know how to fit in first class comments while also, being something that makes sense in a TOML style. So that is a bummer. It's also a bit of a bummer because it's like the start of the stream being like, I don't know how to integrate the theme is like not as fun as actually having a language working. Okay, well, another option is just to like not worry so much about the theme and start building the language out and see if something comes to us as part of it too. So maybe that's actually the strategy that I want to take here. Just have some motion going. And then like as things end up actually like kind of happening, we can sort of see like how this kind of goes. So let's start off. This is just some scratch space, I guess. I'm going to refactor this code a little bit to instead pull this from a file that's the argument that you give it on the command line. So rather than making a bunch of real big arguments at first, I'm just going to use regular old Rust code. So first thing we want to do is use standard env, and then env args, and sure, let's do it this way. Whoa. All right, so if you're not familiar with Rust stuff, basically this is going to pass in an iterator of the different arguments that are used on the command line, so we can like iterate through them. So the first one is going to be the program name, so we want to throw it away. So and then the next one is going to be the file name. And I guess more, it's going to be a file path, really. All right, and so then we can also, I'm probably going to merge those into 2 lines later, but so here, and then we can try to make this happen. So now when we do our cargo run, it's going to complain about please pass the file path as the first argument. So I'm going to make a new, not a new file, I want a new directory called samples. And then we are going to name this hello world.toml. They are TOML files. And let's copy and paste our little example here. I'm gonna take out all this except for this. Let's just get this working as a thing. Samples hello world.toml, and now it prints out successfully that we have our document. So yeah, it is GetLens, totally. That would make sense, JP Tiz, that it's was shared on Telegram. That's cool. All right, so let's save this. And we got our program. Our very first program is going to be print hello world. Yeah, so I like the square brackets as being like call Toml's flexible enough that we can make it do a single argument without needing the brackets, and that will make our lives a little worse. But I think also just like having it like this looks a little cleaner, so I'm just gonna make it do this for now. All right, so let's just like make this work. So the first way we're going to do this is basically like we're just going to make an interpreter that basically like looks for a function named main and then executes the bodies of the statements. So this is going to be like really straightforward and pretty dumb, not sophisticated, just to like get literally anything going. So now that we have a TOML document, the first thing we need to do is actually start looking through how do we actually get the root table and search for the a function, table name function. So I'm going to bring back up the documentation here real quick for the TOML edit crate docs. All right, so if we have our table, then we can see if it contains table name functions. Iter will give you all key value pairs, entry, get mute, and then all these position things. Interesting. So I wonder, is there no root? Interesting. It doesn't actually really, by default, let you see into the root at all. That is interesting. So let's try to iterate over this table and see what it gives me. Yeah. All right, so so the first thing it actually gives me is this function table. So that's cool. So you can see it's got I is a tuple that contains a function and then array of tables. So we're going to check to make sure that what we have is a function. So here's one of those things that gets interesting about like implementing programming languages is you can do it like the real way or you can do it like the hacky way. And so we're going to do everything like the hackiest, dumbest possible way because I just want to get going and have fun with this. So we're going to temporarily require that the top level is always a array of tables called function. So that way we can make more functions later. But for now, we're just going to like hard code basically that there's going to be one function. We're going to make sure it's named main, and we're going to make that happen. So for now, instead of iterating this way, well, what we're going to do is we're going to so all right, so what we're doing here is we're basically getting our iterator, grabbing the first thing, we're calling expect so that we get rid of the option that was there, and that's going to return the name, of the first table and then this array of tables. So I'm saying AOT, just because that's what it is. And so we will then basically say like if name does not equal function, panic, if I can type, that is, must have a an array of tables named function. And then our debug of AOT. So this prints this out. If we change this though to say function 2, it should give us an error message being like, hey, must have an array of tables named function. So that's cool. Our error checking works. All right, and now that we have this array of tables, yeah, exactly. It's an AOT, an array of table compiler. That's very funny. Let's look at the documentation for array of tables. So here we can do an iterator, which returns an iterator of references to tables, which makes total sense. So let's give that a shot. So we're going to grab the first one, sort of the same exact thing. I'm actually just going to copy and paste this because I am extremely lazy. I'm actually not going to do that. Let I in AOT.iter debug I. Why are you mad, VS Code? What did I do? Expect it. Oh, right. 4. Cool. Very good. No method iter found for reference item. But it says we have an array of tables. Let's just run this and see if, yeah, okay. It is annoyed because that is wrong. So it's an item instead. What is an item? An item is an enum. Oh, so it's not actually, let me bring the browser window back up here. It's not actually an array of tables. It's an array of tables, array of tables. That is, it is an item array of tables. So what we want to do here is we want to similar sort of thing. Let me bring this window. Man, I'm going to regret not setting that up too much better. Well, we're going to do this. We're going to say let AOT equals match AOT. And then I actually want to bring item into scope. And then we're going to say item array of tables. And now it's happy and says there's ampersand table here. Cool. So don't need this anymore either. I'm just going to take both of these away. So the thing here is, this is like definitely a thing in Rust that happens from time to time. Basically, like you end up having this, when you do this kind of dynamic parsing like this, it's really interesting because Rust type system is really good, but it also leaves you in these situations where you like know a thing is a thing, but it shouldn't be only this thing, but because you represented it in a way, like basically because iter operates on a generic document, it could return almost anything. But we, in this case, don't want it to be just an item. We want to make sure that it's an array of tables. So what we end up having to doing is matching it and pulling it out rather than doing it the other way. And there's a couple different ways to write this sort of code. I feel like this one is cleanest for now, like, because we sort of want to be like, if it's anything but panic, otherwise keep doing the same thing. So this feels a little weird and kind of backwards. We're like, just return it if it's the thing we want, and then not if it's not. But it just kind of is what it is. And so now this actually gives us a table. And so now we have a table. And so table equals aot.iter.next. All right, and so now with our table, I'm going to say if table.name. Wait, no, it doesn't have a name. It has a list of items. Let's look at the table documentation. Our first table. So now we want to look to see if it contains a key. So we're going to see if it contains a key named name. And specifically if it does not contain the So we're going to panic and say our function must have a name. So let's try to run this. We should get no output because it should be totally fine. Great. And now if we change our toml file to have name 2, it's going to complain function must have a name. So that's cool. And that is good. All right, so now that we made sure that we have a name, let's print out the name of our function. So we're going to say contains key name, and then let's see here. It is going to be entry will give us the value. So let entry equals table.entry name. And now this is an item. Let's change it to be item. Interesting. Oh, because our table is mutable. To get the entry, we can change it since that's kind of the point of this library. And so now it's complaining mute table. Mute not exist. Well, that's annoying. So for our array of tables, we can iterate over the values, but if we do, then we have a immutable iterator. The thing is, we don't actually want anything to be mutable here. So let's see if there's any way that we can get, we don't care so much about this entry being mutable. Is there a, oh, just get instead of entry. Now this should be fine. Sorry. Entry is used to mutate something, whereas the get just gets you the actual value itself. So cool. So now we know we have a, our name is a string, and that is the name. Ugh. Cool. So now we want to validate that the that this name is main. Just because, again, we're super hacking it. So like when we want to make this a little more robust later, what's going to end up happening is we're going to end up creating kind of like a table of all the functions that we know about. So yeah, Lucas, I am temporarily naming the language tins for toml is not syntax. So yeah, that is the current name for this language. So what we'd want to do, yeah, in a real implementation here is we'd actually want to build up a list of like, here are all the functions that we know about, and then end up executing them like afterwards. Right now, we're just kind of trying to like get bootstrapped. So we're going to like want to go through and assume that this is a function named main and we only have one of them, and then we're going to execute it immediately. So this is kind of the first little sort of stage that we're on here. So now that we have this name, we need to validate that it's called main. So let's do that. So we have this value and it is a string. So we're going to need to do something very similar to what we did up here in order to validate that it is a string. So we're going to say let name equals match item, item string. No, item doesn't have a string in it. Oh, right. It's a value. Item has a value of value, and then that would be a string. Whew. Okay, so we have this here, and then we can match value and then say value colon colon string. First of all, we also need to go up here and do one of these. And I don't know what this formatted shenanigans is, but what we can do is we can take this and we can say asster. So we can say s.asster equals so actually don't even need to, we're just validating, we're not actually saving out the particular value of this. So this is roughly what we need to do. But now I'm confused as to why it is missing arm. Oh yeah, right. There we go. What you said about Esther, formatted string. Oh, so this is actually, this is a little easier and better. So we can actually, the value has a bunch of shenanigans in it. And basically it has a bunch of like as or into functions that let us convert it into some sort of thing. So this in theory should print out the exact same thing. Cool. And if we change our name to something that's not main, it's going to complain that function must be named main. So cool. So that is a thing. So we now are validating properly that we have so we got our table of functions and we got main in here. So that's cool. Now we want to fetch the body. So we're going to do the same sort of thing here. And we're going to say let item is get body and print that out. And now it's going to print out the good stuff of the next section. So here we have our value this time is an array, and inside of it has an array of values that is itself its own inline table of shenanigans. So because here's an array, and then it's an array that contains tables. So one thing that's kind of interesting here, I notice this is called an inline table. So this, because this, oh, this is going to be annoying to implement. Because I guess in theory, we can also mandate this. All right, so TOML has a lot of syntax that is the same for various different things. So for example, this is actually the same, I believe we could do like this is what it is, or it's like this, which is less than ideal. So because this is a like format preserving TOML parser, it knows that this table is now an inline table. And I think, let me bring back up the TOML spec. The TOML spec, let's see here, arrays. So it does not actually show an array with a table that is not an inline table. So that's kind of interesting. I wonder if the tables says anything here. Inline tables, blah, 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 more context syntax, group data, curly braces. Yeah, so I'm guessing TOML does not actually have real support for non-inline tables in an array, which is totally fine in terms of what we're trying to accomplish here, but it's an interesting thing to just think about these kind of edge cases. I realize Mateo is sleeping. Yeah. All right. Excuse me. So anyway, back to this after that little digression here. So we have our array. So we have a value that's an array and it contains a list of values. And our first value is an inline table. So that is going to be the thing. Sorry, hold on one second. Turns out I have a package delivered, so I'm going to be right back. Okay, holy crap. I am back. Sorry about that. The my apartment building right now, the doorbell is broken. So when people deliver packages, they normally can get in themselves, but right now they can't. So I have to actually go down and physically get packages. So of course it always happens at the least useful times. So anyway, thanks for sticking with me through that for a second. Cool. 1 second. All right. You couldn't quite see. This guy was very worried that I was going away for a second, but I'm now back. Okay, so where were we? All right, we got our function. We properly get it. We make sure that the name is main. We have that. We make sure that we have a body that exists. Do we actually make sure that we have a body? Yes. Right now we are unwrap. So I actually want to expect must have a body. Hey, thank you. It's okay. He's mad. All right, so stop, please. Go back to sleep. Everything's good. So, all right, we have our buddy. You can't do this. Chill. So we have our body. We expect that it must be a body because it needs to be there. So now we validate that we have the body properly, and now we want to actually like get the particular items because these are the lines of the body that we're going to end up like executing. So, I mean, we're going to execute them, but like whatever. So here we now are back at our same deal with item again. So the same way we had item and a value up here. This time we are going to want to make sure that it is an array because we are going to not let, like in theory, we could actually, like a really minimal version is to make body not even be an array and have it just be an inline table. But we're going to make everybody have an array because I don't want to solve every single possible variant of this shenanigans. So I'm just not going to worry about it right now. We're going to make all bodies be multi-line, even if they're not technically, even if it's only technically one line. So, yeah, different than the actual syntax down here where I said we're going to do each individual one. Let's make it consistent. All right, so we'll end up having that too with arguments also surrounded. That way it's just consistent everywhere. Everywhere there could be one or more things, we're going to always make it an array just to make our lives a little easier. Now we only have to worry about parsing it one way. Maybe 40 hours from now, I can make it slightly nicer to do. Okay, so we need to get our inner table out of here. So we have an array, our value is an array. So let's take this match block like before. And now here, we actually want to do as array, all right, this is all messed up, underscore, 'Let's reformat that real quick. I bet there's a whole bunch of stuff that reformatted. Yeah, totally. That's nice though. All right, so here we now have our array. So that's cool. And now that we have an array, let's go look at the syntax since we hadn't looked at that. So as array gives us an option of an array. And now we can do an iterator to iterate over all values. And we're going to want to do that because we're basically going to like execute each line in order. So for line in A, we're just going to print it all out. We're going to get rid of this last one. Oh, right. We need to actually iterate. I am being dumb. In A dot. All right, and so now we have our inline table. So that's cool. We are going to require this to be an inline table. So same deal as like above, we're going to use some matches. So match line, value, inline table, inline table. It's going to be this. We're going to say that we're only going to support inline tables as the body. And we're going to do this. So let's double check that that works. Cool. We have our inline table. And now our inline table, let me bring up documentation for inline table again. So this is an array. What we want is a value inline table. So we can iterate over the key value pairs. We can also see if it contains a key. But what we really want to do is iterate over the key value pairs, because we're going to have basically each line is going to end up being, right now it's going to be like a function call and then the arguments to that function. Because right now the only thing that our language supports is print. So we have one function called print. So for now we're just going to iterate over it and it's going to be like call the function with those arguments. And so, yeah, so what it does is you can see from the type, it returns an iterator of the key and then a value for the value. So let's do this. So here we're going to, so we're in our specific table. So here now we have each individual line. So we're going to say, oh, that's kind of interesting, I guess, because this is a table. This could actually be more things, but it's not. It's always going to be one. So that's kind of interesting / annoying. This is only ever going to be one thing. We're going to do, let's, I'm going to call this a statement. So we're going to say, oh, it's not iter, it's next. All right, so here, I'm doing it this way for a reason I will explain in a moment, but we're going to iterate over the table and we're going to grab the very first key value pair in the table. So here, for reminders, this is the table that we're operating under. So we're going to have the very first key value pair. So the key should be print and the value should be this array of hello world. So the only thing that we support right now is print. So we're going to say if name does not equal to print, so after we do this, we should be able to, for example, change this to print 2 and run our program, and it's going to complain print is the only function supported. So that's cool. And now it's not going to do anything because we don't do anything with the arguments. So now we have to actually get the arguments to print. So here, now we have a value. We always want to deal with that value as an array. So what we're going to do is same deal, lots of matching. So match args, value array. Well, actually, I guess really we don't need to do the matching ourselves because of the way the value works. Args.as array dot expect arguments must be an array. And so in this case, for now, we're going to start off with print only supporting the first argument is going to be a string literal that it prints out. So we're going to go here and we're going to say, we're going to grab the first one. So now that we have an array, that gives us iter. So contents is a terrible name, but I'm going to do it. So now we have our contents, and so that is a value, and we want to cast it to a string. So we're going to say let contents.as stir. Oh, really? Is it value? Value doesn't have a. Yeah, value should have an as stir. I wonder why. Oh, it's because I typed let. That's why. So now we have this, and hilariously, so now we do println s. Okay, here we go. Big moment. In theory, this should print hello world, right? Hello world. Yeah. It is done. That's amazing. Time to tweet about it because I tweet far too much all the time. And big step forward here. We have a hello world. Perfect. So this is kind of amusing. I'm going to get rid of this value that we imported because that was there only for the example and not really because we use it. Now we shouldn't end up getting complaints. That's cool. We have hello world. So, you know, now we can do hunter 2. Cool. I'm going to change print to puts. just because that's fun. I like scripting languages that puts in, like println. It's too close to Rust in general. We're gonna like make up a slightly different thing. Let's go back to hello world. So that's cool, and that's good. And now, yeah, technically we have a programming language that can print hello world. So that's pretty cool. So yeah. All right. So now that we got that going, that's pretty cool. Yeah, let's see. Now, the next step, I think, to make this useful, I don't think we could, because we haven't. Yeah, right. That was fast. Like this stuff. One of the reasons why I wanted to do this kind of in the stream and also show you this like extremely janky kind of like implementation method is that like it's not that hard. Like you could write a language if you wanted to. I mean, there's definitely a bunch of like work to do, but yeah. Sorry, 1 second, send a little message here. All right. So like, this is all doable. Is this a terrible implementation of a quote unquote language that can only handle one print statement? Yes, totally. Could it be more legitimate? Yes, absolutely. So it just takes work and time. It's like totally reasonable. You can do it in baby steps. So let's start making this a slightly more legitimate implementation of a printing out strings to the screen programming language. So let's go from printing just hello world to printing hello world 2. Right now, if we try to run this, it does actually do it. So that's cool. Why does it actually do this? Well, if we look at our implementation a little bit here, basically what ends up happening is, wait, why does this do this? I'm actually, now I'm surprised. This works because we actually did implement the loop. So darn, I surprised myself by doing too much work as usual. So like hilariously, we can make a function that prints out any number of lines we want by adding new puts. And that's basically because specifically here, we iterated through these and, made this happen. So, there's kind of that as a thing. So that idea for making this more legit is like, not super real. However, the next step would be to like make our own functions that do different things. And so this is going to take a little bit more work, but we can sort of do two different options. We can like do the infrastructure necessary for the interpreter to like process multiple functions, and then we can make it work. Or we can try to refactor this particular implementation to be able to handle multiple functions and then change the parser next. So you sort of kind of like always have these multiple like ways of moving forward when you're like expanding your programming language. Excuse me. And so, that's kind of the thing we can do next. I like working with functions and not like doing things like adding variables, because the variable stuff is like a little harder and more complicated. And so, for right now, we're basically just going to make functions that are able to call other functions. So let's start by extracting this to be something that like is a little more real. It's not that it's not real right now, but it's not like extendable in any way. It's not, if we were trying to define our own functions, this would like basically, not really be actually extendable. I think I'm rambling slightly, but all right. So the way that we're going to do this is a kind of like relatively classic sort of technique. I think anyway, it's been a while since I've worked on a ton of interpreters, honestly, but basically what we're kind of going to do is we're going to create a sort of like global registry of functions that we know how to execute. And so as we go through, we're basically going to defining a new function. Essentially, let me maybe like map this out a little bit. Okay, so strategy is basically like step 1, create a registry of functions. Step 2, when a function is called, look it up in the registry and invoke it. And 3, when defining a new function, you add it to the registry. So this is kind of like the plan of attack for this sort of next sort of step, basically, is like instead of just literally putting, because like the problem is this is not extensible because we only really support like literally the only function name is puts itself. And so the way that we can extend this is by instead having this code interact with the list of all the functions that we understand. So we kind of want to take it from a literally only recognizes one function to recognizes arbitrary functions. And so the way that happens is we're basically going to like make our little registry. And so then whenever we call one, we're going to look it up and invoke it. So these are going to be steps 1 and 2 are what we're going to do to refactor for now. And then we're going to add support for putting new functions in the registry later so that we can have our own functions that do things. So for this, I'm going to use a hash map because we want keys and values of functions and the bodies. Hey, Mr. Vist, thanks for swinging by. It's good to see you. Use standard collections hash map. I'm gonna make a hash map here, and so we're not going to make it global because we're going to put everything inside of main for now because we're just, as I said, we're just hacking around here. It just kind of is what it is. So we have our hash map. It has no contents. So the first thing that we're going to do basically is our hash map is going to have keys that are strings. So that's easy enough. So the first thing we need to do is we basically need to extract the body of doing this into an actual hash map. So the way this is basically going to work is we're going to say functions.insert, and then we need to put in keys and values. So puts is going to be the name of our function, but then the value is trickier. Basically, we need to put in box closures. The function, to make this easy, we're going to basically like not worry about allocations a ton. This will be slow at first. It does not matter because literally no one's going to use this programming language for anything useful. So we're basically going to have this map of function names to function bodies. And so puts, as it happens right now, is going to be this function, and it's going to look like this. And we're going to... One thing that's kind of interesting and a little complicated about, yeah, it's really, really good. And like I'm using Vim mode, so I still get to use all the regular key stuff, KJKL. But the type annotations are awesome for sure. It's definitely very helpful. I honestly have a hard time struggling between like arguing that we shouldn't put named like key value arguments in the language, but also love seeing them in the like this K and V here are like helpful. So I don't know. It's complicated and weird. I think there's something to be said about it being an editor feature instead of a language feature, but I don't know. So one trick, because Rust is statically typed, you may want to make each closure here like take the number of arguments that the function should take. But this is actually not going to like work well for us. And the reason it's not going to work well is because every value has to have the same type to be put into the hash map because Rust needs the keys and the values of the same types as each other. So first of all, it's where we're boxing the closure. So we get the type erasure. So it's a trait object instead of an actual closure because they're all different. But then that also means we need to have the same arguments. So instead of having the number of arguments, we're going to like pass basically like an arguments structure that's going to contain the arguments themselves. And this is going to end up being a TOML array. We're basically going to like pass them all in. Yeah, totally. All right, so, and then here, this means that I bet it is going to complain. So we're going to actually give this a type for real, because this, while impressive, is annoying. Yeah. Yep. You got it. And we're going to make this, well, all right, for now, the strings will eventually need to be capital S strings, but for now we're just going to keep it like this since we only have this. We're going to do as little as possible each iteration. So for right now, we're defining the functions in this map up front, so it's fine. And then here, box, okay, close that out. This is going to be a dyn fn with an argument that is so instead of it being, we're not going to make it a whole TOML edit. We're going to end up also bringing not just value in here, but array. And each of our functions is going to take an array and is not going to return anything. So now you can see Rust Analyzer is able to figure out that this is a TOML array. So that is all good. So we're going to have puts here. And basically what this means is we can take all of this stuff out of the body. I'm going to go back up here. We're going to put it into this like so. And so now this should be a thing that does like the same. Although it's complaining it no longer knows what type this is. That is a little concerning. Why is it suddenly not able to determine? Oh, because, let's see what happens when I run this, just because I'm curious. Okay, it's complaining about the unused args. Right, right, okay. Weird. I guess Rust Analyzer just can't figure that out right now. So that's weird. It's fine. Okay, so now we have this array. What we're gonna do is we're going to look up in our functions list and we're gonna call it that way. So if we go back to functions dot, and then we want to do get name. I'm going to make the error messages terrible because I don't want to deal with interpolating the name into this. Well, yeah, well, it's fine. So now that we have our function, we're going to do, we're going to call f, and we're going to pass in our args like so. And is it mad? Because, yeah, so we actually don't want to expect an array, right? We actually want this to not be an array. We want this to be a reference to an array. So that is all good. Does this work? Hey, it does. Boom. So we've now done the exact same thing. We still have hello world 2, but we've significantly increased the actual like implementation of the language, because now we have this infrastructure in order to be able to like define new functions without rewriting the core. Like we sort of kind of almost went from just a thing that prints out hello world to like a pseudo interpreter in this step, because now we're not actually just hard coding everything. I mean, we're hard coding the entry into a table, but then like our execution is entirely driven by the data itself, right? So we're like actually processing through like what stuff is going on. So that's pretty cool. I'm going to check some messages real quick here for just a moment. So yeah, so now we have this, and what this means is, and like what's cool about why this should be like an interpreter is we should be able to define new functions here, and then they should be usable from our language without changing the logic of the body. So let's make a new function. So we're gonna call this one puts2, and this one is gonna do the exact same thing, but it's gonna print what we have, but add a 2 afterwards. Like, it's just, it is what it is. But this is like the, this is the syntax that we have. So here we're gonna call puts2 and pass in hunter. And so in theory now, we haven't touched our like processing code at all, right? We've just added a line of code to our like program, and we've updated sort of like the built-in functions that our language has. Puts the only function supported. Haha. So hilariously, we forgot, and by we, I mean me, of course, we input this check in here, and this check is now wrong, right? So what we actually want to do is we want to grab the function earlier. So here, what we want to do is we want to do this. So we actually wrote the code. So like, let's see if it makes that smaller. It doesn't. This is one thing that's interesting about the VS Code like expansion stuff, is that this is very long, so it's pushing our stuff way over here, but because it's not in the actual code, it's not gonna like make it down based on what we see. So that's kind of interesting. Anyway, we wrote this code to say that we couldn't find a function, named it. Like, we do this error checking already in this line. So we actually can just like move this up here, and we're getting the function first, and then we're processing the array, and then we're calling what it is. So what is, VS Code is mad because I called cargo format and it didn't update it for some reason. Oh, there we go. It did actually do it. It just didn't update for some reason. So anyway, yeah, so like I said, now this line should be the thing that checks if the function exists or not. And so could not read the file. Oh, because I actually hit a slash at the end. Hello world, hunter2. So boom, we now, like, for some level of interpreter, have like a legit interpreter that knows how to call built-in functions that we've defined. So that's cool. The only thing the functions can do is print stuff out, but like, in theory, we can start to now expand this to do more things. And like fundamentally, when you're implementing a programming language, like this is really all that it is. Like, you just start off with something small and you just iterate and you keep doing more and more things on top of it. And so, yeah, so now we have this function table, and this kind of works. A lot of programming languages that are interpreted have this kind of really interesting distinction between, and even languages that aren't interpreted have this distinction between built-in functions and sort of like standard library functions. So for example, let me bring back up my browser here to show y'all. Why is the Ruby website not a thing? Weird. Okay, so if you look at Ruby, for example, Ruby has two different kinds of sort of standard libraries, if you will. There's the core library and there's the standard library. And both of these are available to you as a programmer of Ruby, but they like contain different stuff. So for example, the CSV library is here, and you can see this is the documentation that it generates. So let's look at the source code, and I bet you can see what the difference is between the two. So here is the source code for the CSV processing standard library. It looks like this. Let's check out the core library and look at, for example, the regular expression implementation. So if we look at a method for regexes, for example, oh, they've changed a bunch of this since last time I was here. Interesting. All right, well, this is no longer in a way that is, oh, here we go. Here's a good one. Let's look at the basic object class. We have these, here's this true or false to negate an object. Let's look at the source code. The big difference between the source code in core methods and the source code in standard library methods is that the core is written in C. You can see RB, OBJ, not, and this is like C code. And the standard library is written in the language itself. So a lot of programming languages do this kind of thing where they have this distinction between the things that are kind of like built into the interpreter and are written in the language that the interpreter has, and the stuff that's kind of like code written in the language that's pre-built into things. And so the way this plays out in Rust, for those of you who are interested in Rust, is a little different than Rust's core standard split. Even though the name is the same in Ruby, it's not the same thing in Rust. So core and standard are both implemented in Rust themselves. But in Rust, we still do have a little bit of stuff that's built in, and that has more to do with like lang items are kind of the way this works. So Rust has these like, oh yeah, totally, I can zoom in. What the exact details are isn't as super important, but yeah, so you have this C code, and then you have this Ruby code. So Rust has this concept called lang items that kind of lets what would normally be things that are written in the like language itself to be written in sort of the outside language. In Rust, they're both the same, so it's like not as clear as in Ruby, which is implemented in C but has standard library in Ruby. But like also there's a thing called compiler built-ins that's part of LLVM that's kind of like intrinsic functions that LLVM knows about. And so you kind of have this sort of like split. So, you know, right now the way that our language is implemented, I'm going to go back to the code. The way that our language is implemented here, this is like these functions are kind of like language built-ins rather than sort of a standard library. So like we haven't really like written a standard library in the language itself, but you can kind of imagine you know, useful functions being sort of like implemented in the language and then sort of like appended into the code that you wrote. And so this is kind of like a really common tactic. And so it can be, there's pros and cons for each of the different styles of thing. Basically, the pros of language built-ins is because they're built in the language of the interpreter itself, that means they can have much deeper integration because they can like reach into the guts of things and mess with stuff. Often in languages that are interpreted as well, that host language is significantly faster. So you'll see stuff be written in the like built-ins because you want it to be fast. Whereas the surface language needs to be put through the interpreter kind of. Like you can kind of almost think of this distinction as like, these are functions that are not, they're implemented in the language of the host. They're not implemented in the language as interpreted. So this println does not need to be like run through our interpreter to execute. That means it's faster. Whereas if this, if this was implemented in the language, it would have to go through our interpreter to be executed, and therefore would end up like being slower. The pro though is that like if you like the language, using it is useful. So like if you implement more in the language itself, that can often be like better. So it is difficult to become a contributor to Ruby because you need to program in C almost as much as you need to program in Ruby. Because if you need to implement something in the interpreter itself or a language built in, you need to know C. If you're working on the standard library, you can only know Ruby. And so there's kind of this interesting push and pull between like a lot of the people who like work on Ruby don't get to program in Ruby because they write C code all day. Obviously they get to do some Ruby too, but just like there's a really interesting kind of like back and forth there. So in our case, the built-ins are going to be implemented in Rust, and I like Rust, so I don't mind. But you know, if I wanted to use my language for something more real, you kind of have to, one of your things that you need to do as a language designer is decide what stuff goes in your standard library and what stuff is a language built in. And there's always like back and forth. And since that's stuff that's exposed to your users, you can change it too. So like sometimes stuff starts off being in the standard library, and then somebody submits a built-in implementation instead that takes advantage of the fact that you're in the sort of like interpreter. Yeah. So cool. So now we've implemented this. Let's instead, so part of the reason I picked Hunter 2 as kind of the example here is, what if we moved Hunter 2 to be defined in our program instead of being defined into the language itself? Cool, Nick. I'm glad that's useful. It's kind of what I wanted to, part of what I wanted to do this is like talk about these sorts of things. So, you know, if anybody has questions about any of this stuff, I am very happy to pause and go into like details about all of these things, for sure. So, yeah, just let me know if I say something that's interesting or confusing or anything. I don't know. We only have, so let's do this. We're going to write puts to in our code itself, but we need to do one brief adjustment for that. So, what we're going to do here is we're actually going to, let's make two built-ins, put and puts. So here, we're going to do put, and this is just going to be print, and then we're going to do puts, which is println. So we have both, with the new line and without the new line. Now, if we run this, hello world 2. So we have both of these. So the idea is that hopefully we can write a function that will take its argument and append the two on its own, basically. So let's start off by defining a new function. So we're going to, all right, we'll do that at the end. Name equals puts2, and body equals, so we don't have arguments support yet. So it's kind of amusing. So we're going to sort of hack it at first. So let's make this body here, and this is going to do puts equals hello world 2. All right, so we're going to do this for now. And so let's see what happens when we run our interpreter. It's totally fine. Why is it totally fine? Like, why didn't this blow up? Well, the thing is that if we go back to our main code here, we only ever actually get the very first thing of the body, right? This is like a match, and we get the body, and we look for an item called name. So what we really need to do here is actually introduce a for loop where we like insert things into the table instead of just doing that. So let's make that happen. So we looked for our table up here. Okay, so we have our array of tables, and then we do iter.next here. So instead of iter.next, what we actually want to do is turn this into a for loop. So let's say for table in, can't spell, in AOT. And now this is now our item. And so we want to pull this out. I'm just going to comment this out for now because I don't know. I feel like I'm missing something slightly. So let's just do that. And then we're going to run Rust format. Okay. Oh, right. In AOT .iter. Cool. Function must be named main because we don't have our function named main. One thing I did realize though, I have not been like committing to Git like at all. So That's bad. Did not make a cargo init, did not make a get ignore? That's annoying. I don't like this at all. Why am I get? I thought get RM would remove it from the staging area, but I guess it did not actually do that. That is annoying. I think this does it. Oh, I bet it's because I didn't actually RM it too. Get RM target. Yeah, it's because I forgot to delete it locally. Okay, so. Thank you, Lloyd. Yeah, that probably would work too. And yeah, Marshall, you should don't hesitate to be like, hey, Steve, you're forgetting to commit. Given this is just like a silly project that I'm not seriously working, like I normally commit too often, not enough, but you know, nobody's perfect. All right, so let's put puts 2 back in here. And let's rerun. I'm so lazy, I've hit up more than I would have if I just actually typed cargo run. Cool, function must be named main. Let's make sure that didn't sneak back in. Yeah, cool, it did not. Given VS Code was showing this little green dot, I was like, is target still gonna be a thing that it's like thinking about? But it's not. Okay, so this is fine. And this is fine, that's all good. So the tricky thing here is that, so we've said our function must be named main. The reason it must be named main is we're only executing the main like function initially. And so that's kind of a thing. The sort of like situation here though is we don't want to actually just take each function as it goes. So we kind of have an issue with the way that we are actually executing stuff. And so I'm actually going to remove puts 2 for now because we need to do a little more refactoring. So I'm going to comment out puts 2. So the issue here is that we're not actually, we're looking to see if a function name's main and then we're executing it immediately. But what actually should be happening here is we should be like processing the main function and like saving the contents of it and then calling it instead. So because like when we want to add puts 2, we don't want to like execute main and then execute puts 2. We want to like define all these functions and then execute them. So now we need a way to save not just our built-in functions, but we also need a way to save our like user defined functions. And so this is where stuff gets like slightly trickier because when we made our built-in functions like this is now like native, Rust code. But what we actually want to do is be able to like save the actual like contents of our functions that we've defined to be able to be calling them later. So we're kind of going to need the decision I'm going to make here. There's like different ways you can do this. Because Rust is statically typed, I'm going to choose to make a second table. We're going to do that same thing with the like core versus standard split. And we're going to mirror like built-in functions and user-defined functions. And there's a little bit of thing we're going to have to do to like make sure the names don't clash and stuff, but it's fine. So I'm going to use a fancy rename functionality of VS Code to do this built-in functions. We're going to rename this to built-in functions. And then we're going to create a second kind of like version of this. And we're going to name this user-defined functions. And instead of this being a hash map with a static string and a boxed closure, what we're instead going to do is we're going to save the body part of the function. So in the same way, this is a key and a value with like, I mean, this is a key and this is a value and this is a key and this is a value, but like in some sense, the name is the key for our function and the body is the value for our function. We're going to stash the contents of the array into this. So what that is, if we remember correctly, is we expect this to be an array. So we have an array up here already. So this is going to not be a box-dine function that takes an array as arguments. It is going to be an array itself with no reference, just an array. It's going to be an owned array of things. So with this being done, now what we can do is we can, we don't want to check to make sure that the function's name is main here anymore because we don't actually care that it is named main. So we're going to remove that stuff. We do care that it has a body though. So, and in the same way, this is kind of funny. You can see when you hack together code like this, you can see here, I check to see if it contains key name. And then here I say expect has a body. This would actually just be easier. This is literally the same thing, but shorter. And we do one less lookup. So this is the thing here, and that's fine. But this is not going to be an right. So before we use this item purely to get this like this. So I'm instead going to, I'm going to change this slightly. We don't actually want to delete all of it because we need to get what the name actually is. So this is what we actually want to do here because we don't want to check that it is some main. What we want to do is instead so we know this has got to be a string. Oh, don't want to do that. So now we have our name that's a string, and here is the here's the trick that we didn't have before. So instead of this being a static stir, these names are going to be user defined. So we don't want string literals. We want to have full capital S strings because we want to save that stuff in there. And so what that means is we go back down here, we actually want to string this as well. And so now we have our name, let name equals, I'm going to do it like this. So now we have our name and we have this whole item that's the body. And so we check that the body is an array. And then here, instead of these lines, we don't want to do this stuff anymore. So I'm going to temporarily comment this out. So we're going to save it because we're going to want to use it. But so now that we have an array, we're going to need to save it. So here we're going to take our user-defined functions and we're going to insert name and then body. I'm going to rename this a body. Do that. And the problem here is it's complaining because this is a reference to an array, not an array itself. And so we need to make a copy of it. So we're going to call clone. And now we have put the body of our TOML into our user-defined functions instead. So that's all good. So now if we run this, it should just do like nothing, basically. Cool. So now what we've done is we've made it so that we can now save additional functions. And so if I do this, in theory, this also should do nothing. Yeah, so that's all good. The trick is now what we want to do is we want to take this code that executes the body of a user-defined function, and we're going to need it to actually execute those things, and we're going to need to want to execute the main function. So let's make that happen. I'm going to take this stuff and move it down here really briefly. And so we're going to insert our function into that, and that's all good. And then now here, what we're going to do is we're going to call user-defined function main. So we're going to make this new function. And the reason we're going to do this is because it's going to be like sort of annoying to interpret the body of things. So yeah, so here, call user-defined function, and name is a string. And then we're actually going to need to pass in user-defined functions here because since we didn't make it a global, we don't actually have access to it inside of the body of this function. So we're gonna, pass it in as an argument instead of making it global. So yeah, we could in theory put this at the bottom, but the thing is that this functionality is going to be useful in the future because eventually, so like, okay, you may wonder, like at the end of the function, you call a function and then you're defining a new function where you call it. Like, why not just put this code at the bottom? I'm thinking just slightly ahead. There's always this tension when you're doing software development between doing the most minimal possible thing that gets your test to pass and then doing things you need in the future. In this case, I'm like doing more work than I need to because I'm putting this out into a function for the future. But like that future is we're going to need this function whenever we have like function bodies that call user-defined functions as part of that. So like when we have main calling puts to, we're going to need to end up like doing this. And so I just want to have it as a function because it'll be useful. And so to call a user-defined function, we need to look up its name and then interpret its contents. So in some ways, this is like the the value of the interpreter of the actual body stuff. So here is our code. I'm going to Rust format. And this is not going to work at all because we don't have a body yet. But basically what we want to do is we're going to look up and see to make sure that this user-defined function is actually in our user-defined functions. And so we're going to say user-defined functions dot get name dot expect could not find again, same deal. It's kind of bullshit, but so right now we're just doing all expect error handling. I want to refactor this into real error handling. I just want to get a little further along before we do it. So I'm overly using like not good error handling. And it's just because like right now, just like does not actually matter if we need to do this or not. So I'm just doing it poorly because I feel like it. It's my personal side project. I'm just not doing it right from the start because I don't care. So this should be the same thing. We look it up and now we should have our body and then we do the interpreting of it. But trick is that we don't have our built-in functions either because that is also, not kind of like, we don't have access to it. That is also global. So we have two options here. We can either make it an argument or we can do something else. I'm going to make it an argument, even though it's gross, in the spirit of doing small things. So we're going to do built-in functions and then same thing here. So built-in functions is a reference to a hash map of static stir. I am just like, I already hate doing this. Where is this up here? I already wrote this giant line. I have one too many bracket here. No, it's not enough. Midas, give me 1 second and I will answer. Okay. So Midas is like, why do you consider it gross to pass it as an argument? It's not that I think that passing it as an argument is inherently gross. It's that once you start passing multiple bits of shared state, so like basically part of the problem here is that I kind of know where I want to go with this. And so it's not that it's inherently gross. It's just that these two things together, the user-defined functions and the built-in functions, these kind of like represent the current like state of our interpreter. And so what really like should be happening here is I should be having a like interpreter state struct, and calling user-defined functions and stuff like should be like a method on that struct, and or we pass in the structs like state to this function as one whole thing. Because like part of why I say it's gross is because like look at the type signatures here. This is just like too much basically. It's not the worst signature that's ever happened. Rust signatures can get really out of control, and this is kind of like not the absolute worst, but it's not great. But like basically just like I think it would be nicer if I had like a state struct with all this information saved into it, because it's like two separate bits of state that we're keeping track of independently currently, not together. So yeah, cool. I'm glad that makes sense to you. We will get there. Just for now, because it's only two things, I'm just going to do it this way. But yeah, so I think in theory, let's try running this. I think at this point it should just work. Unless I'm forgetting something. Hey, there we go. Hello world 2. You're very welcome. Glad to talk about stuff. So now we can effectively define these, but if we, so let's call puts2, which currently takes no arguments. This is going to crash our interpreter right now, I believe. Yeah, could not find a function with that name. Main RS 104. So part of the reason is that our current interpreter only looks for built-in functions. So this is where we start getting into a place where it's like, which one of these two things are we actually calling and which one are we actually doing? So we want to look into built-in function first, but we don't actually want to crash if we don't find a function with that name. What we want to do instead is we want to see if it exists at all first. So let's leave this way. Let's try writing it like this. Let f equals built-in, or we want to say, first thing we want to do is check built-in functions, check user functions, error if neither. So we want to, now that we have these two bits of state, we have to start coordinating, like, okay, we have to look in the built-in functions first or the user functions first. So there's like a deep question about our language semantics here. Like, do we want users to be able to override built-in functions, or do we always call the built-in? And this is kind of like an interesting thing where implementation and semantics kind of like overlap, because like, this is basically, you can do an entire feature of your language by just changing these two lines. Like, if built-ins take precedence over user-defined functions, then users can never overwrite built-ins, because the built-ins are always checked first. So this is a larger concept called name resolution. Basically, we're doing a very tiny name resolution algorithm here, and we're deciding that for the language for now, our name resolution is going to check built-ins first and use them if they exist, and then check user functions. This means that we have less flexibility, because as a user, I'm not allowed to like rewrite a built-in function, but that also is nice because as a user, I can't rewrite built-in functions. And I feel like this specific tiny little choice is one example of how like little decisions can percolate through your language design and change the way that things operate into the future. Because like, this is actually this is probably the first really major choice that we are making in the design of this language, is like, is this a language where anyone can edit anything at any time? Or is this a language where we're limiting the flexibility? Due to how gross this whole thing is with Toml's syntax in general, I'm tempted to do it the other way around, but I think for now, we're going to do it this way. Just to keep something a little bit sane. Yeah, exactly, Mr. Viss. Like, it's like, do you want to let people monkey patch your core library or not? And this is like how this kind of stuff kind of happens. And if it's a thing you don't think about, like, you know, if you've never done this before, you will write your language and you'll have to do something like this. And maybe you put it in a random different order. And then you realize like, oh yeah, that means I'm allowing people to monkey patch my core library or whatever. And so this is kind of the things that you learn when you start writing this stuff. And you also then you end up like learning about languages that you like using. So like, you know, why does Ruby let you monkey patch literally anything? And it's like, well, because it does this, and it doesn't literally do this. It doesn't do it the same way. It doesn't do it in the same order, but like conceptually, it's kind of the same idea. Like, do you let people do this or not? So that's all good. I want to take a brief, as a sleepy boy right there. He's passed out. Yeah, big stretch. All right. So enough brief Mateo. Okay, so what we want to do here is we're going to check our built-in functions to see if it exists. So one annoying thing about this is you check it and then you check it and then you error and then you have to actually look it up. Like adding two pieces of state is like kind of really annoying. All right, so first we're gonna take our built-in and instead of it being get, if let some built-in functions dot the auto filling stuff in messes with my head sometimes. If let some this is f equals built-in functions dot get name curly, then call the built-in function. Else if let some f equals user defined functions dot get name, else panic could not find function named name. All right. So we've determined that our built-in functions for now only supports arguments as an array, and then so we're gonna cheat just to try this out, and we're gonna panic on calling user-defined function, and so just to see if this code actually works to some degree. So yeah, calling user-defined functions is not supported yet. So we went to go look up when puts2 happened. Let's comment this out and just make sure that our put still works. Hello world, done. Interesting. Put gave a new line there. Did it? Put a hello world? Is that just, maybe that's cargo doing that? I feel like now there's a bug. Okay, it's not actually doing a new line. Cargo is doing a new line. Oh, cargo didn't used to do a new line after all output. I bet that's what's happening. That's weird and confusing. It's probably better this way, but that's annoying. Okay, so we still haven't broken our original code. If we call built-ins, we're totally fine. But now we need to call our user function. So let's do that. So now that we have, let's see, where is this here? Yeah, that's a good point. Let me do that real quick. Or no, debug. And then it's going to be samples hello world automl. Suspicious. Is it that I'm doing a I'm not doing any println anywhere else. Whoa. I don't like it. I don't like it one bit. Maybe it's my shell. I don't know. I don't want to spend a ton of time debugging this, but I do think it's questionable. Weird. I don't know. I don't like it. Okay. So we're going to copy our same code from calling our user-defined functions as our built-in functions. But the problem is it's going to be sad about this. It's not going to work properly. The reason is that we have an array here, not an actual function. And so that is an issue. So here's like, this is where we get to like now needing to like actually sort of like interpret the body of our function. So it's more interesting. So we don't need this args as array because, we do need the args as array because that gives us the array of arguments. But we, the function body itself, we need to actually do stuff with. So here we end up doing something very similar to this, where we have to iterate through it. So we're going to have to go through each individual line. And right now, the only thing that we do is support calling functions. So we're going to need to do that. So what's interesting here is I'm actually going to change the name of this slightly, because if you notice, I got the name wrong. So it's no longer called user-defined function, because we look up the built-in functions and we look up user-defined functions. So what we're actually going to do is we're going to actually do this call function instead, because we have both and we're looking at both. So we now have our array, and basically the way that we're going to do this is we're going to say let me go look back up the definition of, don't need this Ruby anymore, array. Iter will give us a iterator over all values. So that's good. Go away. There we are. So I guess we're calling them lines in we're going to rename this f to body, because it is the body of the function as opposed to the function itself, which is what f is up here. So we don't need this anymore. And because we don't really support using arguments to things that are user-defined functions, or the bodies are just going to do whatever we're doing. So now here we have these values. And so each of these values in this case we've determined has to be an inline table, which is what we did up here. So let's just, for now, let's do this. Debug line. Let's print out our interesting. Let's print out a hello world. All right, we commented outputs too. So now we have our inline table again. So we need to look that up appropriately. So we are getting the body and it's showing what this is. So that's fine. So let's see here. This is a value. So we need to do the same thing as before with value where it is going to be an inline table. So we say match line value inline table and then body has to be an inline table for our stuff to work. So that's fine. This is the same actually here. So let's make the error message the same. The body of functions must be inline tables. Oh darn! Close that by accident. And yeah, the fact that it's similar is definitely a little bit of a, you know. So we got that, and then we're going to do the same sort of thing here. So we're going to take this. We already have this stuff here. And one more indent. All right, so we got that. And now we have a name and we have args. And so we're going to recursively call ourselves with the name and user-defined functions and built-in functions. And that is that. I I believe now it's going to complain, yeah, about args, because we basically don't really support args all ton. That needs to be IT and args here. I think this now should work. Could not find a function with that name. Boo. Wait a minute. Could not find function, could not find function with. Oh, right, because call functions itself only looks up user-defined functions. So we're chasing around the fact that this is ultimately recursive, and so I was trying to not like get the immediate part of it. You can see that we're starting to define a bunch of the stuff in and of itself, etc. So originally this was call undefined functions. We've changed it to call functions. So now it's kind of just like eating itself, basically. So now I'm like, oh man, I have messed up the recursive aspect of this. And what we really need to do is we need to change this. Let's commit where we are in a second. All right, so we kind of like have this defined already partially. And so what I'm going to end up actually doing here is we started defining it of itself, and then we got into it. We ended up starting defining itself again. So that is pretty silly. So what we're going to end up actually doing is we're going to take this out here, and instead of it being this, we're going to cut out this bit. I think this is the last one. Args, it's not in scope. Where is args? Right, so args is a reference to array. Right, because I think that's what it is. Where is args up here? Right, we want to start off by calling this with we need it to be an array that is empty. Is there an array new? Oh, bummer, that's annoying. I'm not sure. Let me look at let me show you the documentation for array. So if we look at it, basically there is like no particular immediate way to just like create an array, which is really annoying. Because we basically need to kick off calling this with, you know, with no args. So we need to create an array. We can do something really silly. Yeah, is it default? Did it have default implemented? Oh, nice. Yeah, thanks. Sharp eye. Very good. I was like, man, that's really annoying that doesn't exist. Cool. And now we can pass in blank args. That should be fine. This is now as an array. Oh, cool. What is, oh yeah, you're totally right. That's awesome. Returns an empty array of tables. The thing is, hey, why are you mad? Mateo is very mad. Because we, buddy, it's okay. It's okay. Sometimes when he wakes up, he gets cranky because he hears a noise and that wakes him up and then he's like scared about it. And so whatever. Yeah. Thank you, both Mischievous and Midas. Those are good calls. The thing is, we actually don't need it to be an array because we need it to be a value because, so we have options here. So like previously we called it with a value and then got this as array out of here because of that. And so I think that if we just comment this out, is it going to be happy? Call function on 107. Yeah, so now we can pass through our args. So the thing is here, args is a value. So we kind of like, we have to like pick basically, yeah. So what I'm gonna end up doing is, this is actually gonna be a value and there is a value function that will just give me an array that's a value. So I think that is maybe, no, that value returns an item, not a value. Let's see if, okay, the enum is, all right, so value array default. Hey. Thank you for being protected, but it is unnecessary. He's so mad. Boom. Hello world. Hello world 2. You should be happy, not mad. I just did a thing. So yeah, sick. We now have our own user-defined functions, and we have they can call built-in functions. So this is getting there. Time to tweet screenshots, because that's how I celebrate things. He's a good dog, but it is very silly. All right, so yeah, it's important. I like tweeting this stuff not only just like give shared progress, but also it's a good like timestamp. Like I can go back and find out when this happened and be like, yeah, like that was a time that was good. Yeah, that's pretty good. All right, so somebody tweeted and replied to me and said, obviously you need to be able to comment on first class comments, which gives you higher order comments. Oh, I'm so sorry about that, Isaac. I will try to make him not bark, but that's definitely there's a dog across the hall from me, and so sometimes when it barks, it'll make him bark, and then sometimes vice versa. So luckily that's not too bad. But usually it's that he'll hear another dog outside. There's like a park really close to my place, and yeah, it's a thing. So that's a thing. Cool. So yeah, back to what we actually did here. Now we have user-defined functions. We can define functions. Cool. I'm glad it's not a problem. It's for some reason specifically like dogs barking bugs me as a sound. Like just I don't know it's why specifically, but it like gets me upset. Obviously I don't want it to be like happening, but it's just like it ruins my concentration. Honestly, I get really knocked out of things whenever I hear it. So I'm glad it's just funny. So okay, so back to the things. Hey Blur. Yeah, we're doing some code. So we can define functions, and our main function will be invoked. We can call user-defined functions, and we can call built-in functions. So that's pretty cool. We kind of have multiple ways we can sort of go from here. The first thing is we could do functions with arguments, because right now we don't support arguments whatsoever on our functions. So that's a thing that we need to be able to do. We can work on enhancing put, because right now it only can print a literal string, but it would be helpful if it could print, multiple different things. We could add variables. It's kind of a lot of like ways to go to make this a slightly more useful language than it is currently, which basically right now can just only print stuff out. So that is definitely a thing. I'm still a little concerned about this weird bug with so like it is not printing the new line here, so that's totally fine. I wonder what happens if I change this to a put instead of puts. It's still putting that new line. It's only after the program is exiting. This is and it's literally only doing it at the end. Like it's weird. I would expect some sort of strange bug to where it changed the definition of like put to be puts. I was thinking that was the problem, but it clearly is not that. So that is a deal. Cool. I think at this point, one of the things I want to do. Okay, there's a couple different things. So we can do variables. We can do enhance puts to print out more things. We can do functions that take arguments. We can also refactor the state of our kind of like interpreter a little bit. That might actually be useful now that we're kind of at this part of the game. And we also might, I don't know, want to do some other stuff too. I think the way that I currently want to do this is, I think I might want to do the next thing being refactoring this to have a real like interpreter state instead of it being a thing where we just pass around this stuff. Like this basically should be turned into a real thing. So I think that's what I might do next, but I'm not 100% sure. Yeah. I am going to step away for about a minute or two and throw away my empty cans and do some stuff. So I'm going to be right back. And I guess given this is going to be a longer one, I'm going to make a quick scene on my OBS that actually does this. So let's see here. I forget entirely. I think I thought there was a write something on the screen scene thing. Yeah, I can do this and then do text verb. Cool. That's not exactly in the middle, but it is going to be a thing. Oh, hey, what's up? Sadly, you showed up right as I'm about to take a quick break. So I will be right back. But I'm glad to see you here. I'm not going to be very long. It's just going to be like 5 minutes. We just need to take a second. All right, be right back. Okay, I am back. Yeah, there we are. Mateo's now chilling out. He gets this weird look on his face sometimes. It's a little far away, so you can't really see. His eyes get all like, ah. He gets intense. Yeah, so, all right, first thing I'm going to do is actually commit this. I guess I'm doing this on my other terminal instead of the one that you can see. Let's go back over here. Thanks. All right, now we're all cleaned up. So I think the first thing I want to do is actually refactor. He is a good puppy. I want to refactor this like interpreter state into its own thing, because I think that is going to be useful in making the code cleaner, and it also means that we are going to be able to like do better going forward. So let's do a little bit of cleanup on that. So the first thing we're going to do is we're going to make a struct, and it is going to be a VM struct. So we're going to call this a virtual machine, and in it we're going to have built-in functions, and that is going to just be this. And we're going to have our user-defined functions. It is a Mountain Dew, actually. I normally, I've been on a soda kick lately. I kind of quit drinking soda for a while, and that was nice. And then I stopped. Oh, hey Andrew. Yeah, I didn't see your question. Sorry, I got lost in there. I am in fact using NewShell. 0320. I don't know if that's the newest one. New works well enough for me that I don't update it nearly often enough. So it just it is what it is. I don't know. It's good. I mean, everything works out. Okay, so we have our VM here, and we are going to write little accessor functions for this. Maybe it is the shell that's doing it too. I feel like I've seen it. I've been using NewShell for a couple years at this point. I feel like I've seen it do the other thing, but it is entirely possible. Oh, I guess the reason I don't think it's the shell is because I went into PowerShell and did the same thing. So it's a little unsure about that. Maybe it's the Visual Studio Code terminal, not the shell. It's doing that wouldn't make any sense. I don't know. Anyway, yeah, so let's encapsulate this a little bit better. So let's also do this. We're gonna do yeah, I've heard good things about fish. I just have not really used it much myself. Okay, so we're gonna do this, and we're gonna do this, and then this becomes the problem. It's complaining because this is not a trait object. I don't actually want this to be a trait object. I am totally just drawing a blank on the taking a closure as an argument syntax because I am being silly about it. course it is because I'm streaming. I'm just like, wait a minute. What I want to do is make this generic. And then this is now self dot built-in functions. That should be totally fine. And then this becomes, so we're going to say let VM equals VM. That is all good. We forgot the box. Oh no, there's a box there. So that's cool. The body should not be this though. Ends up being F. And by F I mean body. Right, so the issue here is that because this is a method, it's going to connect all of these together. So that should be all good. Right, so this is now helpful because we are doing all that. This goes away. I want to do a similar this becomes not this anymore, but now becomes basically this, because we're going to take the signature is slightly different. We no longer are taking this here. We're now taking a array. This is a, oh, can't vim. That is good. Define built-in function, define user-defined functions. All right, that's all good. Now we need this down here to be vm.define user-defined function with the name and body.clone. Or no, we do the, is that fine? Right. So this is kind of an interesting little like brief aside. You could argue two ways. You could argue that the user-defined function should take in the reference to the array and then call a clone inside it, or you can do the clone outside and do it inside. And so basically, I'm choosing to do it outside because of the fact that technically this function is asking for what it needs, which is just an array. Because I copied this over, I'm unnecessarily cloning it. Thank you, Vikaku, for saying what's up. But basically, like, I would rather make this take an array and put it in than have it take a reference to array and clone it inside, because this means if I happen to have an owned array, I can always pass it in without doing a copy. So like, this feels less ergonomic in the case where I always have a reference to an array, but it allows me to elide a copy in the case where I already have an owned array. And so it's definitely a trade-off, basically, between those two things. I personally prefer to do it this way. Glad that you agree. So this does mean that I need to do the clone outside here, and that's totally fine. We've almost managed to refactor everything. This is now going to be a function inside of our interpreters. So we're going to do vm.callFunction main args. Oh, thank you, DJ Renan. That is perfect. Amazing. That would be, spooky is the right word for there. That would be that'd be something. Yeah, we should just, do we need to mutate ourselves? Is it going to argue? Let's see what happens. I think this is fine. Did I not delete the arguments off the end there? I thought I did. I did not. And this becomes self, and this becomes self. Oh yeah, right. There's also these ones. This goes away. So this becomes tricky. So here's part of the weirdness about this is hello too. We are back. We have fixed our definitions. So one thing that I'm not 100% sure about with doing this kind of like thing in general is that stuff can definitely be weird. Because see, like, one thing that's interesting and good about Rust, but also can make implementing this kind of thing awkward, is that call function what's that with the no new line? Yeah, it's hello world, hello world 2, which is what it's been doing, which is weird. I don't know why it's doing that. I still have not figured that bug out yet. So because call function takes self, this means that it can't change the interpreter's own state while it's running. So like what's interesting here is, I want to cargo format this. Basically with this definition of call function, we now can't mutate our interpreter while our functions are being executed. And that is a good thing in some senses, but it also means that for now, we're actually like limiting our ability to do like meta programming, because a function can't define its own function. Like if we were to call define userland function inside of call function, that would take mute self, and we only take immutable self. So it's kind of interesting too. This is why I paused for a second, because I was like, I don't know if this is actually correct in that what we want to do for the semantics right now. And I wonder if it's going to cause problems later. I'm curious what happens if I just change this to immutable self. Is it going to also work? I think it might. No, see, so we start running into the borrow checker here, which is really interesting. So the problem is that we are then getting immutable borrows to our like built-in hash maps. Yeah, I'll talk about that in 1 second. So we end up running afoul of the borrow checker because we end up needing to use a mutable reference to call a function, but we're like immutably iterating over the contents of stuff. And that's kind of like, weird. So this may be a bit tricky, and we'll sort of figure out how it goes as we go along. It also is the root of like, if you've done Ruby or Python and you've heard people talk about like the GIL or like the global VM lock or those kind of things, that ends up happening for this exact reason. If you multi-thread things and then you start changing the interpreter state for multiple threads, you have problems. So this is like preemptively saving us from those kinds of issues in the future. So for now, we're good, and we're just gonna leave it like this, but this is just a thing to point out for later. Might be a giant pain. We'll see what happens. It also might just be totally fine, and that we're gonna say like this part of, we may want to make these, interior mutable somehow. We may want to, not, like we'll see what happens. But one side effect of turning this into a VM struct is that, that's going to start to be an issue. The borrow checker is going to be doing some things. Okay, so Karthik, shouldn't we give it an explicit call stack heap for VM to run? So yeah, I mean, you can do that if you want to. I'm not building this implementation that way because I'm doing this more in the tradition of like a really classic, simple, straightforward implementation of it just runs as it executes. Because like the thing is that, for example, right here, you may know that call function itself ends up actually being recursive. And so that means right now we are subject to Stack Overflow. And so that's just like is what it is. I'm not worrying about it because it's a 48-hour jam, but it is like it's a side effect of how we're doing these things. And yeah, if I was going to do like a more like a VM that was like a bytecode interpreter VM kind of thing, like that might be totally true. But also part of the reason why that stuff doesn't exist is we have no variables yet. So there is no state. So like having explicit state object doesn't make sense because there just currently is no state. As we add in things like variables, that stuff may be more necessary, and we'll end up adding it. Naso, good to see you. And yes, I it's not statically typed, so there's no generics. So variadric generics is totally fine, not a big deal. I haven't decided if I want to make functions variadric or not. Right now there literally is arguments are like not possible, basically. Like the only thing that takes arguments is built-ins. Regular defined functions can't take arguments. So that is a future extension. We'll see what happens. Yeah. WASM Playground will be fun. I should do that. The real big open question is about the first class comments, because that's the theme. I still don't know how to integrate the theme with this project, because first class comments is weird in TOML. I'm not entirely sure. I don't know what to do about that. It's still bugging me. Haven't figured it out just yet. So yeah, even just the syntax of it is a little awkward. We did some brainstorming at the start of the stream about how to pull this off, and I didn't have any good ideas, partially because TOML's syntax is being a little weird. And so I was like, I want to actually get to coding, and so I'm going to implement some stuff first, and then we can worry about that later. I think what's going to end up having to happen is we're going to end up having to use sigils and strings. Yeah, that is the, Marshall. I think maybe what you said is a thing that makes me. I briefly thought about that, or like, what if it was the concept of first class, like a first class airline ticket? Like, what if comments are just like special or something like that? That would be an even better. Oh yeah, that's also a good point. It doesn't necessarily have to mean that it's the first class in the TOML itself. It could be a comment in the language, right? Because so originally my idea was not Turing complete TOML, it was homoiconic TOML. And so if comments are a language built in that does nothing, then that would be a first class concept. Like, what if it is like that actually is legit. And not compiled the first class isn't documented is very funny. That would be a good thing. But Midas, I think maybe you're right. Maybe that's actually the thing. And I think if I still haven't totally figured out how exactly I get homoiconicity in the TOML itself. I think I need to be able to manipulate TOML inside of TOML. And I think like you could do something similar with like car and cutter, but they're like the first of an array. You just have to have way more of them because TOML has more concepts than Lisp does. But I bet if I have built-ins that let you manipulate the TOML itself, then that would be good for my original idea. But I think that we could make this happen. Why is it? Oh, it's because of the lack of comma there. Yeah. Okay. So, Midas, I think you may have temporarily saved me. At least so that it's consistent with the theme. Let's at least put comments as a built-in that does nothing, because I think that's cool and useful. I think also I do like the brackets. So here's what we're also going to do to make it first class, I guess. Let's make it so that comments are the only thing that are allowed to not have an argument list. Well, I don't know. All right, for now we're going to do this. We're going to make this happen. But first, let's make sure this works. All right. So now it should fail and complain about could not find function in comment. Yeah, a global comment array would make sense too. Eventually. I guess I'm worrying too much about being useful in a language that's like fundamentally not useful at all. All right, so let's go to our built-ins and we're going to define a built-in named comment, and it is just literally going to do nothing. And now this should work, I think. Yep. Yeah, I was thinking about that too, Mischievous. I feel like, I don't know if it's like, so the very first thing I did was like end up, like I looked at the way that this particular library handles comments. And what's really interesting about it, and I think it makes sense given its function, it doesn't treat TOML comments as its own thing. Like if I did this, what it ends up doing is it ends up making it be part of the node of this, but just like with a preamble text, because it treats it as like formatting basically. So that's kind of a thing. So it's sort of interesting, but yeah. I think this will definitely be good enough for now. The thing about first class, it just really depends on what you mean by first class, because like the sort of the definition of first class is often like store them in a variable, or like they're treated like any other thing you can do with them. So it's, I don't know. This is probably good enough. I mean, it's not like I'm trying to win, quote unquote. It's not like they're a super big winner, but like I feel like I want to engage with the theme in some fashion. For now, this at least goes from like nothing. Yeah, exactly, Andrew. Like I feel like it should be meta programmable. However, as I said, I think that like if I can make it be this actual like built-in function that does nothing, and this means that I could do this meta programming stuff with like the whole it being homo-iconic, and that would let you manipulate comments the same way that you would manipulate anything else. So that's kind of, yeah, exactly. High order comments. Oh man. Yeah, storing comments in variables. So that's actually part of the, maybe this is a good, let's see. Hold on one second. So one thing that is unsolved yet for my problems here is I don't know what the syntax. Yeah, that's pretty funny. Commenting on those things. Yeah, like, so it should be in some time, like doing something with some sort of like runtime value, I guess. I wonder, it'd be kind of interesting. I wonder if there's a thing where like it becomes standard error, like the secondary output, instead of it just being, printing stuff to the screen, but you could also like append comments as your program runs. Like what if like log lines are comments? And this is kind of combining the idea of this, like the interpreter comments on the execution of your script. Like what if comments are like literal, it is talking about your program as it's executing, and that becomes like basically log lines or something. But yeah, I think there's sort of an interesting thing with like, Python's like doc strings have code in them, and that's like a comment in the code or code in the comment. That's kind of like related. So, but I think with this, I think with my original idea of homoiconicity and this would end up working because you'd be able to manipulate the comment like any other line of code. So I kind of feel like that's okay. But back to what I was saying a second ago, totally losing my train of thought, getting too deep into things. Here's a good. He sleeps. He hears me say it though, so then he wakes up a little bit. But I don't yet know how to do variables in this TOML syntax. So I think probably the next thing that we should be doing is variables. And there's a couple of different things. Yeah, that is, yeah, metaprogramming the functions themselves, or like templating. I don't know. I feel like So yeah, it's like, hey Shai, thanks for stopping by. There's the dog. You can hear him all the time when we're playing, but you never get to see him. So like, there is a question about like how I actually even represent variables in this syntax. There's also some really hilarious things it could do where like, so there's a couple, I had one idea from before. So like, let me bring up my browser window here. I think I still have, nope, I don't. That's not the right browser window. This is the right browser window. KNRC basically had function arguments have their types be defined up here. And then also in older C code, you needed to not just define the parameter type separately, but also you needed to define all the variables that we're using up front rather than like later. And so one of the things I was thinking I could do in terms of variables syntax is like, oh, edge. There's some people that do, I'm sure. So like we could like do this as a thing, and then that ends up becoming the variables that you can use later in the program, and specifically like in this. Yeah, and so maybe a sigil is the right call for like doing a thing. The problem with using a name starting with $sign is that it becomes not toml anymore, and I want this to be valid toml. So it would have to be, I think you can do like I could do a string. I think keys are valid strings. So that in theory would be a thing. And yeah, that would be interesting because the equals, having this where you can like assign equals as a value is definitely funny. But yeah, also that's a good idea with like set and get as built-ins. And that was kind of also what I was thinking is funny too. If we wanted to truly make this a terrible programming language, instead of there being a stack, we could just like all variables are global. Like I think not only is it a little easier implementation wise, but also I think it would be very hilarious just to like make it bad. And so basically all variables are global. And then also maybe be good, maybe like start off that way and then make them not global later. Might be a decent refactoring too. So yeah, let's do that. Let's implement variables as a built-in function. Yeah, SSA variables. Yeah, right. As it executes, it crashes your interpreter. That's pretty funny. Okay, so let's add a variable into our. So we're gonna do set. Yeah, see, like there's lots of stuff. I kind of unironically think that this syntax is better than I would initially give it credit for, maybe. So let's do this first. So we'll make it so that we can do set and then a value of set to 5. So this should end up crashing. Yeah. Oh, toml parse error. Unexpected. Wait, what? Line 5, column 5. Huh. Why is it not happy? Do I have the... Do arrays have to be the same? Mixed type arrays are allowed. Arrays can contain values of the same data types as allowed in key value pairs. That's fine. What's interesting too is it says at line 5, column 5, unexpected. Is it? Let's see if. Okay. Yeah. It's that it does not allow heterogeneous. At least this one does not allow it, apparently. Even though it says. Oh, let me show you the spec. I wonder if this is a bug in the TOML library. Arrays are square brackets with values inside. Elements are separated by commas. Arrays can contain values of the same data types as allowed in key value pairs. Values of different types may be mixed. But when it shows it, it says nested mixed array, and it's got like two different ones, but within each array, and it says mixed type arrays are allowed, and it shows floats and whole values. So yeah, it seems like it's saying it's expecting array closing. Yeah, that's the thing, right? Like it can't just be that. I wonder if it's a bug in TOML edit. Let's go. I wonder if that's a new feature. I bet maybe it's not a bug. It's just that older TOML does not support it. I wonder if that's the issue. Let's see. Where is the... This is the TOML 1.0 spec. What if... This is 1.0.0. Array. Data types may not be mixed. Different ways to define strings should be considered the same types, and so should arrays with different types. Oh, ooh, ouch. Cool. So we are limited by the library we're using. Oh, that sucks. That sucks real bad. I'm gonna eat an Oreo while I think about this. Now, so I was using TOML edit because I don't know if you've seen the pull request to add cargo edit to cargo, but I've really wanted that for like 3 years now. Never worked up the time to actually do it. And the task that's currently blocking it is about integrating TOML edit and TOML into cargo and like crap like that. So I want to get more familiar with cargo edit. So there's two paths forward, I guess. The first one is I wonder if cargo, if the TOML crate does support this or not, because that is an option. Currently compliant with the 0.5 version of TOML. So it doesn't support TOML 1.0 either, which was January. So I wonder if, let's see, I doubt. Yeah, so allow heterogeneous values and arrays. So the TOML crate did merge support for this. So that would be an option. Yeah, totally. I mean, also, another option would be to just literally only allow for strings. Because, you know, this is a silly, fun language, not a you know, serious language. And so maybe the answer is just temporarily, okay, we do it as strings only and just leave it at that for now. That also might be fine, I guess. Yeah, and you're totally right. There is other things that we can do. Let's see. Yeah, set like because like, oh yeah, that would be no, because then that would be, yeah. Okay, I think that is very funny. Maybe that's a good thing for the comments. I think, yeah, for now, let's just make everything strings. If it's good enough for Tickle, it's good enough for me. I think that's what I'm going to go with for now. It'll just be strings. This is a thing that can be changed later, and I don't want to get too caught up in the libraries being dumb. I guess in theory, we could redo with the toml crate too and use the head version with that branch. It's kind of annoying. Here's you want really trolly, you call a transmute and now it's not a thing. Oh yeah, that's a good comment, Isaac. It could make it more of a special form. Yeah, or the, yeah, like put it in here too. Totally right, that would be possible. I kind of like the idea of transmute because I think it's hilarious. Yeah, let's make set. I think maybe set as a special form makes the most sense because I love that the equals does make it feel like a assignment. Like I think is the reason that I think that is pretty much a thing. So yeah, let's go with Isaac's idea. I think that's cool. I think all these are good ideas, but I'd like to make some progress, and I like how the equals seems like assignment. So let's do x equals 5 like this. The goal is to do some gross shenanigans with toml. I just like wanted to come up with an idea for like what's the dumbest thing I could do, and the answer was make toml a programming language. So I haven't really thought through much more else than that. So yeah. All right. Oh, it's like now there's also a funny thing where I'm like imagining, what if I just made it Lisp where you square brackets instead of curly brackets, and then it would just be actually toml. Anyway, that's a whole, I'm already too far down the like make it look really like toml road, but there's a universe in which writing a Lisp with square brackets, it would count as toml. That'd be kind of funny. Anyway. All right. So let's do it this way. So now this is going to break. Could not find a function named set. And the other thing about this being set, that is very funny, Midas. I'm dying. All right, so we're gonna define a function set, and we're gonna add some variables into our VM here. And then this is going to end up actually being a value. Because that'll give us all of our native TOML types. And then, yeah, I think this actually ends up starting to give us the, I like the special form version. The other things are hilarious and also trolly, but now that I'm thinking about it too, if we do this where set doesn't give you just a value where we define them, but it gives you any TOML value, we're now getting to my like homoiconic idea where like the variables are also specifically the types that are in TOML. And so that's like kind of closer to the spirit of trolliness of what I'm doing. So I think that's kind of actually ingenious. So, all right, let's see here. What was I doing? Yeah, so we got a string and a value for variables, and then set is taking args. And now we are going to do self dot or wait, no. So if we make it a built-in, it's not going to make it a built-in function. It does not actually have a reference to itself in the body. And so that means that doesn't work. So we can also make that also has to be basically its own. Oh yeah, I mean, I pretty much was trying to do I mean, a Lisp is always a good idea for jams, but like, it just, yeah, I figure we'll get there. A TOML as Lisp is like, it's very silly. So I guess what we actually want to do here is entry, and then name dot insert, or like we're going to do or insert. Well, is it or insert we actually want to do? Because yeah, I mean, if it doesn't exist, we want to do, I guess it's no matter what it is, it's, let's see. It's just insert because we always want to put it in. We don't want to give it a default and then modify it. So just insert value. Why is it complaining? Is that not in a method on entry? Oh, interesting. That's unstable. Boo. All right, time for some crimes. And by crimes, I mean this is, so yeah, basically is if it's occupied, then it does entry to insert, and if it's vacant, so we're gonna do this. This is the code. Yeah, it seems like that's true. Maybe that just gives me a good opportunity to do this again in the in another jam in the future. I guess actually I'm going to do this. It's not that vec. Oh, is vec entry not stable? The issue here is hash map. Entry is stable. It is insert on entry that's not stable. This part. So I'm just inlining its definition from the standard library. And I don't actually care about returning the value, so come on. Yeah, needs more crime is correct. Now I'm just like, how much do I want to do all this versus like actually freaking blah, 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 blah. I could just insert a dummy value and then overwrite it no matter what. Does value implement default? It does not. Cool, Jason. I'll catch you later. Thanks for stopping by. Yeah, it's. I think Rust people especially love to use crimes as a description. I guess. Well, Isaac, I was thinking about updating it because the problem is insert. Maybe you're right. Maybe I'm just being silly. I always think about entry as a thing. Let me double check hash map insert. That's probably just what I need. I'm overthinking it. Hash map insert. If it's not present, oh yeah, totally. You're right. I just need insert. Thank you. Value. I need to actually put the value in there. Just insert this name. No big deal. Yeah, insert will just overwrite it and it's totally fine. All right, so set variable. And so now what we're going to do is we're going to define a built-in function called set that wait a minute. The problem is we still end up in the same thing where because we define it specially, we need to handle it specially. So I would really ideally like to do that. This is going to be annoying because this is going to capture the VM. Blah, 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 blah. Is this even going to compile? Yeah, see, this is going to not compile because it's going to complain about can't capture the VM itself with set variable. So this is where we get into like even more built-ins. It's like, okay, is this a thing that's not even able to be defined as a built-in function because of the fact that it does not have access to its own list of variables, which is annoying. How do I want to handle this? I'm not actually sure. Like maybe it just ends up being gross because like I can also then just change my like so where is this? So what I can do, probably what I'll just do because it's yeah, I probably can. I'm just like let's do the dumbest, hackiest thing there is, which is inside of call function, we're first going to do this. This is fine. Oh, here we go. This is what I said. So we run into our first issue where now we're trying to mutate the environment. Isn't that what I just said before we implemented this? We're going to have a problem when we try to want to mutate the environment from a thing that is not actually there. So this is where we have choices to make. Yes, of course, NASA. That definitely happened. So we can do a couple different things here. One thing that many language implementations did originally is just literally put the entire VM instance behind a mutex. And anytime you want to modify it, just the entire world state is held onto. That is simple, and it guarantees you don't have lots of weird problems, but it's very slow because it means you can't change different things different times. So you can split it up so they're smaller, and that will help. But then that means that sometimes you can get into deadlocks when you lock part of a thing and you need the other part, and you do some other things. So I think what we're going to do here is we're gonna get cursed because this is 48 hours and I don't care that much. It's time for a thing I almost never do. I don't even remember where it is in the standard library. That's how bad I'm being right now. What am I trying to do? We're trying to do. It's time for ref cell. I'm sure there is one somewhere, but we're just not going to care that much about it. Yeah, it's not like this is going to be a thing where people are going to be... There we go. Now, everything is fine. Oops. This might be the first time I've legitimately used ref cell in my entire time doing Rust forever. Oh, right. So actually, I want to do this. My, yeah, my, yeah, it's funny. Definitely. So this is a good example, I think, to briefly wax philosophical about Rust. Like, I think that this is the kind of thing where different people feel differently about writing things in Rust. So like, on one hand, there's people that would be like, how do I possibly make it so I can do immutable and immutable borrow at the same time? And then you get into this whole situation where a lot of stuff sort of like is annoying and terrible. And then like the other thing you can do is like try to do the simplest possible thing, which in this case is just wrap this part in refcell. This might come back to bite us later. So for example, one thing here that I really love about Rust, and one thing why you don't get to do this specifically in a lot of other languages, is that we have created a ticking time bomb, basically, in that we are now doing some mutation in a not thread safe way. So if I started to add threads to my language, which threaded TOML is maybe too much, maybe not, we'll see. If I added threads here, someday in the future, this would blow up. But because of Rust's borrow rules, it will catch me later and be like, refcell is not actually, it's not allowed. And so that's really, really helpful. Because like people basically, if I was doing this in C, I would reach for a mutex or something like that immediately, because I would know that someday I'm going to want to add threads and I want to make sure that this is safe. And if I don't, or I don't do that, and then someday I add threads and I get weird errors all the time. And so what's kind of nice about this is that this is sort of, and like the reason I'm choosing this path in this particular moment is we're not trying to like, we're just, it's literally even a temporary, like it's just borrow mute and insert for this, just this one little temporary statement. So there's going to be no chance of this actually panicking, because even if we had some sort of like, like we're not, it doesn't even last longer than one line. So it's basically not going to cause a big giant problem. But if it started to get more complicated, then there's times that it becomes a problem. So I feel okay with this. But yeah, it's definitely, you can see it in different ways, and you can like argue about whether Rust is like a problem here or whatever. I don't know. I feel like a lot of people have feelings about this. Now I'm looking at my Twitter replies really quickly. And people are starting to notice. Yeah, it's pretty funny. Oh, thanks for the shout out, Marshall. All right. Well, okay. So now we can set variables. So that's cool. Now we need a way to actually print the value of variables. And so I think it's time to enhance. It's true. You only get one or the other. It's time to enhance put to interpolate, I think. So there's a couple options here. The first thing we can do is maybe, but no, the problem is, see, this is also where it gets annoying, because like what I want to do is like this doesn't work. I could do this. That's fine. A little awkward. I could do this. This is less terrible. Still kind of more terrible in other ways. So that's the thing. Right now, our language is very expression oriented, or is very statement oriented, not expression oriented. Because like You also could argue that like this is a thing to do, or this is a thing to do. But this, I think, will not be allowed because of the Tamil heterogeneity issue. Because, like, see, because this is already a string, so that doesn't work. So another way we could do it is put the actual, like, just completely embrace this is the Ruby style with that or it's $. This is the Ruby style. This is a thing that's coming to Rust eventually. We could just like grab X from our global hash map and do that as a thing. That would be a possibility to do this interpolation. This means we now have to like parse the strings that we're doing, and that's like annoying. I don't really want to do that. It's fine. I'm just lazy. Ugh. So yeah, those are options. I don't know. I don't know what I want to do. It's a good question. What does named arguments in a map look like to you, Naso? The problem with that, Karthik, is that it doesn't, those forms don't match with the string that's being passed to put. Like part of the fundamental problem is that put is taking a string as an argument, and therefore all of its arguments need to be strings. And so even if we did get the value in one of those ways, those aren't strings, those are tables. Oh, God. Oh, that's... Ooh, that's also a good idea, Midas. But, oh, Naso, that's amazingly cursed. Yeah, I guess you could do it always as an array of dicts too. It's okay, bud. Something's got the dog feeling spicy. All right. Well, the comments thing is fun. Oh, that's an interesting question, Marshall. Yeah, that does work. So that would be a good, yeah, literally each one is an array. But the problem, I guess, is that gets you strings, but it doesn't get you bare names. Because like really what we want is something like this. And this doesn't work because X is not its own thing. Like if it has to be a string too, you might as well just remove the inner arrays. It does give you number literals and other Tamil types, but it doesn't really give you the name. I think what it might I actually think maybe formatting does need something closer to what NASA originally put, which would work, because we could do something like this. Yeah, that's kind of where I was starting to think, is something kind of like that. Like, what if it was... No, what was I thinking? Bracket, bracket, comma. All right, hold on. Yeah, I think this is just not a thing, unfortunately. Yeah. It's true. We really do get there. Whack bite, you're totally right. Like that is, I think that might be where we have to end up going, is like similar to what NASA was saying earlier, like basically okay, like this. Did it actually parse correctly? Yeah, that's gonna fail, but then you go like format equals this, and then you end up having like a grab bag of x equals what did I screw up? That, I think. Yeah, okay. Yeah, I think this is basically what you had written earlier, NASA, but it's got one less level of indirection. No, it is literally what you wrote earlier. Except for, well, no, you had format and then a pattern and then a value. And I just have format equals this. And then, yeah. I think this might be the best that we can do. Yeah, thank you. I think this might actually be the best we can do. It is a little verbose, but if anyone is complaining that my TOML based programming language syntax is too verbose, they can not use it. I guess too, this would be like maybe easier read. Oh God. Yeah, I guess that's also true. You could say that that's like that would let you do right. Like this basically just inherently binds to X because we're a shorthand. Yeah, this I think this might be the right way to go. All right, Zach. Thanks so much. I'll catch you later. Uh this might be the right call for now for a short thing, and then we can do that form as like the longer form if we need better formatting. Because our variables are yeah, it's true. Because our variables are global anyway, get the value doesn't, I think, make a whole ton of sense, because like who cares, basically. All right, well, I'm going to think about this for 30 seconds. I am going to take a like 2-minute break, I need to get another drink and check on some things real fast. So I will be right back in a minute or two, not super long, and we'll implement some string formatting. Okay, here we are. Yes, it is very funny that it's very funny that all variables are global right now. I kind of like it for the trolley part of things, but it's also very silly. It's like, I don't know. It's good for fine. Yeah, totally. That is also all variables live for the static lifetime, basically. So we're good on GCs. All right. Okay, so string formatting. I feel like there's got to be a Rust library to do formatting already. It is true that could be a thing. Um, we shall see. Um, it is because like I mean honestly, variables and functions sharing the same namespace, it actually like might be better. Like, okay. So the thing is that like we have basically built different namespaces here. But we could, because variables have any value, like I think it's actually a really good, this is a really good point actually. Like because variables have any value, like a variable could be set to the code of a function body. Like the way that this is written right now, like x equals 5 is just as legitimate as like x equals puts equals hello world. Like this does work. So you could argue that by creating a like function and variable namespace, we're like creating an artificial distinction that does not actually exist. And that basically like defining a function like this is the same as calling set with the name X and the body of that. Like, yeah, like that could actually be a thing. And like what's funny about this too is like technically, all right, I'm gonna make a copy of hello world.toml. Let's mess around with this a little bit because so like this ends up becoming sort of the same as like if you wanted to do a script version of this. I think this is actually, oh no, because you need the root is a table. So you end up being like this is actually totally fine from a TOML's point of view. And so we could actually like back up slightly and like quote unquote clean it up slightly by like basically just like making lambda calculus. I don't know how much I want to change this at this point though, but like there is a decent argument to be made that like simplifying it more would make it more consistent. Yeah, exactly, right? Like that's what kind of where I'm thinking about, Mr. Vis. Like and then like numbers become piano arithmetic. And you just start going the whole way down that entire like yeah, basically, right. You like get by like calling X, you get its function. Because like there's not really a reason to do get X equals 5 when you could just like get X. Now, so are you saying that the thing I said is what is in crafting interpreters, or are you about to leave another comment with what they teach you? I do like the idea of making this language more orthogonal and more cursed. And so maybe this is the path I want to go down. I gotta like think about this. It's clearly very important. Right. Hey, what's up? What's up, Ibrahim? We're talking about if we want to transform this into something a little more lispy, maybe. Basically, so I feel like oh yeah, I mean, I read the book as it was being. Oh, so this is. I see. I thought you were making a statement, not like a question or whatever. Yeah, I get it now. Uh, I read the book as it was being made online, and I purchased the book because I like physical books. But I haven't. I started to implement the first interpreter in Rust, and then got bored and gave up. Basically, but it's a really good book. I've read it all. It was just like that was the second read through. I was like building it. I was like, eh. And so I didn't want to mess with it more, but yeah. So yeah, if we did a thing where basically everything was, if we went back to like everything as an expression, basically, and we wouldn't need this syntax to be this way, because this is also a little like heavier weight than it has to be, because we already have keys and values. So making name is the body, is the like this, and the body is this. Like this is actually unnecessary, because like this basically just has a lot of extra ornamentation around it that we don't strictly speaking need. Because if you think about it, like this is a key and this is a value, and this is a key and this is a value. So basically you take, I'm gonna go back over here. All right, so it's easier to see in puts two. So like this is a key and a value, and this is a key and a value. So if we just puts two, then this goes away. And then we don't need function anymore, because also at the top level, it's totally like there's basically an anonymous table at the top level. So this then becomes this. And this is already a simplification of the outside. Yeah. And so like, I actually think that this is a good direction to move in, because then we can also become more like expression-y basically. And if everything becomes a TOML value, like we're basically moving, like part of the problem right now basically is like in this code that we basically have a value type and a function type. But if the functions are also like literally made of values, like this, like technically variables, like right now, functions are a subtype of variables. Yeah, exactly. Like that's just like totally fine, basically. And so like the thing is this, like the way we've ended up developing this, like variables are a hash map from a string to value, but a function is a hash map from a string to an array. So there's no reason why this also just shouldn't be, a function shouldn't just be a value, and just literally everything is just names and values. So I think this is the direction I want to go. This is actually correct. And then basically everything becomes an expression, everything becomes more simplified, everything's in the same namespace. Like it doesn't actually matter. I think this is fun. Let's see where we're at right now. Removed put and added some sets and puts and stuff. All right. And we did the ref cell shenanigans. Okay, this prints this out, and that's fine. Let's not worry about this. Yeah, it is just functional. You're right. We had to choose object-oriented or functional, Nasso. You're totally right. It's just, it ended up having to happen. We're choosing functional TOML, and I think that was always what was in my heart anyway. All right, so let's get to work messing with this. This is going to require a bunch of chainsawing. Let's go back to, we're going to kill this, and we'll kill this, and this main. All right. Time for some major surgery. Oh, yeah. Yeah, I see what you're saying. You just literally, that's main. Yeah, that's funny. I don't think I'm going to go that far, but that is funny. Okay. So let's take our VM, and now we're going to call this values. I'm going to move the ref cell. Still going to keep it a hash map. I'm going to change this to I guess we'll probably still need the ref cell actually. Let's leave it in. Leave that there. We no longer need to worry about, this is call function. I'm gonna just comment this out for now. In theory, everything could be immutable. That's true, I guess. Not gonna worry about this anymore. Not gonna worry about this anymore. Not gonna worry about this anymore. Okay. We don't care about array of a table's name function anymore. I guess I'm just gonna freaking comment this all out. We're gonna start basically all over again, which is fine. That is true. It is, no one's gonna use my language unless it's got highly parallelizable coroutines. You're not wrong. Okay. Unclosed delimiter. Psh, whatever. All right, so here we have, right, the table with the name. So I'm gonna do something like this. Oh, right. This is. Right, so name equals main, and then item equals value. So what we want to do when we get this very first thing is we basically want to call vm.setValue, and we're going to pass in the name as the name, and we're going to pass the value as the value. And so now we have properly set up our initial VM state. And I guess Functomal. Ooh, that's good. That's good. Maybe I'll change the name of my project. Functomal. That is hilarious. Name, string, and a value's value. Weird. Expected value found item. I always forget the difference between the value and the item in TOML. Edit as value. Item is a type representing a value table or an array of tables, and a value is a particular TOML value. Right, so it's giving me getting there. I think Rust Analyzer is messing up and expected a value but found an item, right? Because it could either be a value, a table, or an array of tables. And so I really, can't a value itself be a table? Oh, okay. So I guess really, I don't want this to be a value. I want this to be in, is it true? Because, okay, so basically Tom monadal. So an item can be a value, a table, or an array of tables. And a value can be an integer, string, float, datetime, boolean, array, or inline table. So like on some level, yeah, I guess we do want that to be a value. And just like, I don't really fully appreciate why there's items versus values here, but we're gonna mess with this. So I mean, why not? Why should we restrict it to always be a function? Is the thing. Like, yeah, it probably practically should be, but so if it's a value, it is a value. If it's a table, then what I want to do is I want to create a I guess I don't care if it's an inline table or if it's an array of tables. I guess I really do want it to be just a value. And then this is .clone. This doesn't derive debug. All right. We got it. We got a value. It's an array of values that are inline tables, blah, 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 blah. So that's cool. Yeah, I mean, if we reduced everything to set and get, then that would be the same. Yes. Big stretch. Okay, so now we have this. I think what we want to sort of do is when we're interpreting this, so like when we're doing the equivalent of call function, because basically the key is what we want to do now is we want to do like basically vm.call function main. Like we want to, we end up calling the main function that we defined. So yeah. So like call function is actually, shouldn't really be call function. It should be like eval, right? We really want to like eval the symbol main. That's really what we're trying to do here. Yeah, totally. That would be a way to do that assignment. All right, so if we want to eval, I guess we want to be expression oriented, so we really want to also like return a value. Hey. The dog is waking up a little bit. Yes, Midas, you are totally right. I will need to loop over all the top entries. For now, I am doing one, but that is a great call. We should come back to that for sure. All right, so let's see. So we're going to eval main. So what we're basically going to do is we want to look up. Well, so first of all, I guess we're going to do something very similar. We're basically recreating the code we already did, just like a slightly different names in a slightly different ways. So if name equals puts, because we still need to have puts is like actually a primitive. So, and I guess this is also going to be, because the thing is we also need to eval. So if we're just evaluating main, we don't, I'm trying to think about because like if we're just evaluating the things itself, then we don't really have arguments in this new universe, right? Like, because like main is itself just like a thing that gets evaluated to a value. And so we do need arguments in some form though. Because see, like in this form, main becomes slightly different because then this is like an argument to main is this array as opposed to the body of main. I guess main has no arguments. This is sort of similar to Rust where, okay, so main is a function that gets invoked with no arguments. And then puts is a function that does get invoked with the arguments. Yeah, like we need to do like syscalls like that. So, all right, so when we eval a symbol, we're also going to need to do arguments. And that's also going to be a value, a reference to a value. And so then here, this is the same deal as before. We basically do like, was it value default? How did we do this before? Oh yeah, here we go. Value array default. I found that sometimes when you have a small project like this, just rewriting it makes a lot of sense. Even though we are going to be mostly doing the same thing, it's just like a little easier. Okay, so we didn't actually implement this yet, so that's why it's confused. If name equals puts, then we want to do so here puts is arguments is what we're going to print out. So And we sort of like this is kind of like our empty value is like an empty array, which is kind of silly. Okay, so VM does not need to be mutable anymore. So we're not actually mutating anything inside of it. So that's cool. So now we're not getting any output, which is a little strange. I'm sure there's a good reason why. So we're evaluating main. So when we evaluate main, we just look to see if the name is puts, and it's not. So that's the problem. We just literally did not implement looking up main. So that's fine. I'm going to do this for now. So I guess I feel like I'm now making mistakes. I feel like I had a really solid approach before, and now I'm like losing it slightly. Because so here, so okay, so we're calling main with no values, so we need to look up. So like self.values.borrow dot entry. And I don't really want entry. We want like get name. So this is now we would have the value of main, and we want to like eval this if it exists. So like this is here, and then we're gonna do like self.eval. But like, see, we don't have a name anymore as the thing. Like, well, I'm just assuming that main gets automatically called. Because like, okay, now we have a value, and we want to do our, I guess we're doing this stuff now. Because okay, so in here, value would now be, I'm gonna just do this. Right, if it's an array, I want to loop over each statement, totally right. And now the temporaries are, that should fix that. Right, so if, exactly, if it's an array, we want to loop over it. So we're going to do match value. And this becomes array for I in array iter. And then this becomes a value. So now we have, in this case, the inline table, because we want these to be inline tables, because this is what it's going to have to be. So match I item inline. It has a value inline table. Table, yeah. Just habit. I find unimplemented hard to type, and it ends up being very close, and so I'm just doing that. You're totally right that I think unimplemented is probably better, although I think in some cases, I'm not entirely sure yet. I think part of the reason I'm using panic not supported instead of unimplemented is that I don't actually know what I'm going to support, if I'm going to support all of possible values in all possible ways here or not, because it feels like maybe that doesn't actually totally make complete sense, basically. Yeah, to do would also totally make sense too. I always forget that it exists. Right, so now we have our inline table. And we can iterate over our inline table. And now this has the strings and the values. And so here is where, yeah, I think it might be undefined behavior as a thing. So here's now where we have another name and args, because we have a string and a value. And so now we want to do self dot eval oh, right. This is not going to actually have a thing. Yeah, I thought we'd end up panicking somewhere. $23. Puts. Oh, right, because I didn't, I made puts not actually a string. I made puts an array. Hello, world. It added quotes around it. I wonder what this formatted string is in. I think I want to cast. Like this. Yeah. There we go. Okay. Now we're getting something that's a little more kind of like lispy. A little more everything is an expression. And I think that this is kind of more of the direction I would really like to go. One thing that's interesting is that I'm not entirely sure. I felt like this was going to panic. Because now that we're recursive, does the ref cell get held across the recursive call? I guess this is actually a value. This is not this ref. And it calls it and returns a ref to the inner thing. And then I guess that lets it go. I wonder if this is a case where non-lexical lifetimes is actually saving me. I wonder if this is then fine. I'm curious if any of you fellow rusty people, I honestly expected this to panic. Once I started calling eval and itself down here, I was like, this is, this is not a thing. Finally, hilariously, you'll also notice that we return nothing. But if we want to do the actual good syntax, which is that it gives you the final value of the final thing, we would need to save the value that comes out of the last thing and return it down here. Yeah, that would be some pretty silly extra series of things. Hey, bud, let's maybe not do that, huh? Maybe. Oh, you want to say hi? Oh, there's my boy right there. Okay. Mateo's now up and getting a little anxious, so I may have to take a little break. We'll see how it goes. So this is the thing. We also, I don't want to forget about, I believe it was Midas mentioned that we need to loop over all things here. Somebody did. Sorry, I don't remember who that was. It's been a minute. Only enter the non-built-in part once right now, so only one borrow. Yeah, I feel like this is gonna get bad. Okay. Buddy. So then puts to, let's go back and start doing the way we used to do it here. Puts hello to. This is kind of funny because we need empty calls are very silly. Yeah, so lookup failed. Get a kind of a nice little thing there. Mister, are you being misbehaved? Arrays for assignments and dictionary for declarations. Yeah, that might work. All right, I want to... It's this one now, so we needed to do for name item in doc.iter. Yes, it is the unit type. You're right, Amatus. It's probably fine because I am borrowing it immutably. Hello and hello too. So yeah, we already have this working. so that now we just basically just by looping over it now calls, and that's totally fine. So yeah, I'm feeling good about this particular iteration. This definitely feels. Come on, bud. All right, see you later, Karthik. Thanks for hanging out. This definitely feels better. I feel like we're getting to a spot where it is more. Yeah, he really did. Should have named him Phoenix, right? We're getting a little less special cased. The syntax is a little bit nicer, and we're going to be able to do the like homoiconic thing a little bit better because we're now like treating all values as one thing. We don't have globals. We can't overwrite stuff, which is kind of a little wild, but it should be fine. And yeah, so I guess. Yeah, right now it's not a problem because we're only doing it immutably. I still feel like this set value is a problem. We'll see what happens. Thank you for the reminder. Time to do a little tweet. All right. So I think that what I'm going to do is I'm going to take a little bit of a break, specifically because it's almost 6 o'clock and I got to take the dog out for dinner and a walk from like 7 to 7:30. So I think since it's almost 6, I'm gonna give it like 15 minutes of hanging out, but I am gonna like probably take like 2 hours and then come back after he walks. So I think that the next 15 minutes I'm gonna plan out like what is gonna happen next, and then yeah, I'm gonna drop out for a little bit and come back later. Yeah, that is very good, Midas. That's very funny. So that's good. So yeah, so I think next steps to get back to where we were before, we're gonna need to get back to implementing variables like assignment. Right now, these are built-ins that are called like functions, but we want to I think basically like the next step is to implement like set equals x. Oh, now I forget what our set syntax was. You're welcome, Mr. Thanks for hanging out. It's always good. It's always a good time. I think setting the variable, and I totally forget now where we were at with this. It's like, because we have the name and then we have the value, and we want the value to be a toml of some kind. Oh, right. It's that set is itself a table where x is any sort of toml value. Right. Yeah, lookup failed because it doesn't know what set is. Well, yeah, okay. So set is, if we do a table where the set is the name and the value is get, that works. Yeah, totally. Maybe once we're not in like freaking level 5 COVID again anymore, and I can actually hang out with people, that would be awesome. I think because I think NASA, yeah, you're right, except for the fact that we don't need to do the set and the value, because if this is the case, this also means we could do, for example, like y equals get x, right? Like this should be parsable. Yeah, totally. So this would be like get and set. And so I think that this is probably the direction that I want to head next, is figuring out how to do these variables. And this is where I think I'm going to get into my ref cell panicking, because we're now recursively trying to modify the ref cell as we loop over it. Yeah, totally. And set does gain the ability pretty natively to set multiple values at the same time. So that seems good. I am concerned about this eval situation. I feel like it's going to be a problem. Yeah, cool. All right. Well, yeah, I will see y'all in 2 hours and 12 minutes. Until then, I'll catch you on Twitter, etc.